had a very good weather yesterday, and the evening was also cold, so everyone is well refreshed. Please, the first row. Dufie. Madame Dorothy. So then you know the pattern. Please, first row, please. Yes. Bernard is coming. Yes. Good morning. All right. So, looks like we still have some stubborn academy guys here. They still don't want to move forward. But we'll start nonetheless. Okay, so please, those of us, I know you are interested in networking, but those of us at the back, please come in. Let's start quickly. Okay, so as has been our tradition here, we start our programs with prayer, so we'll start with a prayer. I'll pray for us to start. Father, we thank you for a successful program yesterday. We pray that today we'll have an even amazing program so that the objectives set for today will be achieved. In Jesus' name have we prayed, amen. Okay, so you are welcome to day 2 of our Tweek 2025. Yesterday marked the beginning of the opening session, and we had an amazing time. As you are aware, Tweek 2025, the theme is from the breadboard to the boardroom, and the sub-theme this year is Connect, Innovate, Create. And so whenever we say Tweek 25, you have to say Connect, Innovate, Create. All right? So shall we try it? Tweek 25. Oh, I'm not feeling the vim in the room. Tweek 25. And I think all these are action words, isn't it? Yes, so let's do it again. Tweek 25. Well, I don't know the signs for connect, innovate, and create, but we just imagine them. Oh, I've seen some hands among the students. Somebody was saying connect. But whatever it is, these are action words. Let me hear that from your voice. So yesterday we started the program, and as you are aware, the program is looking at how to turn prototypes into useful businesses or useful products. And so each of the days have been themed. Yesterday we were looking at innovation and prototyping. And so all the things we talked about, if you paid attention, were skewed towards innovation and prototyping. So each of the days, that is how we've designed that. Today we are talking about product development and scaling. So after you've had the idea that you think will work and you've done some prototype, day 2 will look at how do you develop the product and how do you scale it. And day 3 will look at entrepreneurship and commercialization issues. People always say that engineers or scientists do not know how to make money. And there's a popular saying I always share with those of you who are close to me, that they say that engineers or scientists are the camels behind which merchants ride to prosperity. So what it means is that we are tools that people use us to make money, not us ourselves. And we want to change that narrative. And so maybe by the end of Tweek, we will no longer be camels at the back at which merchants ride to prosperity, but we will be the road, or the instrument to prosperity itself. And so that is how the program has been designed to equip us along this particular process. So yesterday, we'll do a small recap for yesterday. And to help us do that, we'll do a small quiz. Yesterday, almost everything failed, but that is part of engineering, right? You do things, they don't go according to plan, you come back again. Today, we fixed everything. So nothing will fail today. Oh, well, should I say nothing will fail? But we'll minimize the possibility of failure. That's the right word to use. So today we'll take a short quiz, And as we promised yesterday, every day we will elect a champion. Yesterday we couldn't do that. So today we'll have a champion for the day. Tomorrow we'll have a champion for the day. And we have an interesting prize for the respective champions. So if you are ready, the production team is ready. I was going to summarize, but we'll take a small quiz. So let's look at the board and let's roll. So you can just go to quiz.com and type the code there. And remember, usually the questions are also not always from what you heard. There are things related to what you heard. I think that's a good way to test our understanding. Otherwise, I know some people recorded everything verbatim. So there could be things related to what you heard, and we'll see. So whilst we join, let me give you some quick overview, but I won't give you the details. So yesterday we had an address from the Vice Chancellor, our mother, who stressed on our value as youth and the fact that we should not let what is happening around us belittle our potential, but we should believe in ourselves and stand for what we stand for, which is excellence, and keep pushing boundaries. Then we had a keynote address from Mr. Romeo Bujay from IT Consortium. I will leave some details out because of the quiz, but he gave us an exposition on how and why he joined KNUST. It was because of the greenery. Luckily, we still have the greenery, despite the galamsey going on. But we still kept the greenery on campus. And then he told us about the multiple times that they have failed as far as product development and iterations, and how far ITC has come. And largely because we have to be resilient, we should have integrity. What we say we'll do, we do. And we should just stick to our promises and have a certain good track record of delivery. You see how I'm leaving some details out. Then we had a guest presentation from Bernard from 4th IR. He took us through the entire prototyping sequence or cycle, gave us interesting examples, and I'll just list two of the examples. The one of the strongest man, who those days, people were measured based on their strength, but now it's no longer the case. And he tried to challenge a machine. After that, he died. Then the fastest or the best coders, this time a human being beat AI, but the guy really struggled. I don't think next time you can, because whatever data that he used, AI has learned from that. Next time, AI will beat the best coder. The essential thing is that do I add that? No, I'll leave that out after the test. But in summary, we were made to understand that we have to see AI as a companion or as a tool that can really shorten the prototyping cycle for us. Something that used to take 3 years will now take weeks. Something that takes weeks can take hours. My team, let's keep it on the screen for people to join. Yes. Okay, so I wanted us to get to 200 and then we stop. But in the next, we are still joining. Okay. Okay, so those of us who want connectivity, the SSID still holds. So it's Tweek 2025, and the pass key is Tweek at 2025. At as the symbol. Okay. All right. Okay, so I think, should we start? Those saying no, why? Okay, let's start. Okay, so let's start. Whilst we play, those who join can join. Okay, so let's start. Team, let's roll. promise today we'll have a smooth sail. Which of the following is an example of using AI in the prototype phase of design thinking? They all look like good answers. Okay, so let's see. Let's go to the next one. Let's see who are leading. So you have ambitious leading. Okay, when different departments share their data with an AI tool for a joint goal, this is what? Oh, jeez. Okay, so it appears my promise didn't work. I should minimize you are minimizing the losses. Looks like this iteration is not working. So whilst we do that, please, those of us in the middle, I don't know why you're afraid of the front row. Please move forward. If you were sharing gold bars, I'm sure all of you will want to come forward. No, there's no one holding a gun here. So to kill those in front. Please, my people, come forward. Yes, the middle row. Who listen? We are starting again. No. Okay, so we'll proceed along the line. We'll do the review because I can't let my prize go waste. So no matter what, we'll do it along the program. So today is focusing on product development and scaling, and we'll be listening to amazing presentations. And today's program is largely interactive. We want to give you examples of the real world, how some of the things we've been saying have been working. So we'll have partners giving us exposition with respect to the topics that we will be sharing with you. And then please feel free to ask questions thereafter. We'll have amazing speakers today, and I want you to take advantage of that to ask all the relevant questions after their presentations. So we'll have presentations from various partners, following which there will be an opportunity to ask them questions based on their presentations, or related questions. So those of us who are having questions on product development, you have an idea, but how do you move from there? Some people have nice products, but they don't even know the costing. How do you cost it to make sure you make money? Sometimes you ask someone, okay, everything you've done, how are you going to make money? I don't know. Anything you give me will be fine. I don't know whether even what I'm going to do, it's going to make sense to the customers, but I think it's a good idea. We've learned that having a nice idea without a business plan or something that will turn it into something useful is just a hobby. You are just working on prototypes as a hobby, but I want to move beyond that. So today we'll be having these amazing presentations on that. So let me give you a preview of that. So we'll be having a presentation from Mr. Philip Kwenu from Heidelberg Materials Digital Lab. We'll have one from Mr. Samajedu, and then we'll have one from a very special guest, which I'll leave it as a surprise. He went through the same things that all of you have gone through. Started from basic electronics, and he got a spark from basic electronics. a course that most of you do not really like. All right. But he got his idea from that area. And he is not a typical computer engineering student. He wasn't a typical computer engineering student. So it would be great to listen to him. I will not give a spoiler on that one. And so when he comes, I expect a lot of questions to him, because he was once in your seats now. And even without the extra help that people were giving, he's navigated the chaos, and he's making impact. I'm using one of his products at home, actually. And so it means that it's good. And it was right from among your midst. Okay, so at this point, I would, is our questions ready? You still don't want me to give out the prizes. Okay, so then we're going to move on to talk about our presentations for the day. So I will invite the moderators to upstage. Invite the moderator upstage to take over from me. And I wish you a very, very, very fruitful day. I know today will be very, very remarkable. All the best to all of us. Thank you.
Thank you very much, Professor Akowa, for reminding us about what happened at Tweek Day 1. Are you excited for Tweek Day 2? Well, I hope you have your questions in mind, because today is going to be a very, very interactive session where panelists will talk about things relating to scaling a product and then how you yourself can scale your prototype to a bigger thing. One thing I noted from Prof was when he mentioned that engineers are usually the camels which merchants ride to prosperity. So today, let us not be the camels today. Let us learn something that will make us actually the merchants plus the camels that will move or ride us to prosperity. So today we have two plenary discussions that will focus around the central theme for today, which is product development and scaling. So our first plenary discussion will follow a series of conversations regarding designing tomorrow, turning prototypes into scalable products, which means that we as engineers usually produce prototypes. Our AI models, our microcontrollers, and all other devices that we create on the lower levels are prototypes. But when we want to move it to a business, we will have to scale it so that it can be multifunctional and it can fit the needs of a demographic or a market. So we'll be having a series of speakers that will come and talk about this topic. So for our speakers, please, when you come up to speak, you speak for 15 minutes, kindly take a seat down so that when it's time for the question and answers to be easier to reach. So for our first speaker today, our first speaker is a seasoned software engineer with over a decade of experience in leading high-performing teams to deliver cutting-edge software across diverse sectors. As a lead software engineer at Heidelberg Materials Digital Hub Ghana, he drives full-stack development using Netcore and React. He mentors engineering talent and leads strategic initiatives, including conferences, hackathons, and workshops. The speaker for today holds a BSc in Computer Engineering from K University, an executive MBA in Project Management from the University of Ghana. He is recognized for fostering collaborative work cultures, promoting innovation, and delivering enterprise-grade solutions that solve real-world problems. Our first speaker today is Mr. Philip Kwenu, the lead engineer for Heidelberg Materials Digital Hub Ghana. Please just give a round of applause.
Good morning, everyone. So it's a presentation, so maybe can I have my slides? I don't know if I can get a microphone. presentation. Yeah. Okay, so we are talking about designing prototypes into scalable products. It's I would want a microphone that I can move around. I don't like this one. Okay, so no, the technical team should collaborate with me, cooperate. I want a microphone to move around. Okay, let's go ahead. Okay, so we are going to look at the steps required to move from idea to scalable product. So I've had the chance to interact with students during the final year defense, and we have great ideas, prototype, but the question I kept asking myself is how we are going to move these ideas into scalable products. So I'll give a quote about the subject matter, and then the journey from idea to product, then product creation at large scale, and then the requirement and steps, the critical steps you are going to go through just to achieve what you want. So can we have the next slide? So in plain words, you can think of a prototype as a seed of innovation. Very small that you can plant and...
Mic, 1, 2. Yeah. Sound, check.
Okay, so a seed of innovation, small enough to plant, yet with great potential to grow into something scalable enough to change your world. Most of the great products you have in this world were ideas. Very small. People have dreams. People just face some real world problems, and then they get an idea to start something. So prototypes don't just come out of nothing. They come out of small or little challenges people face or people identify within the environment or the part of the world they find themselves, or information that they've been exposed to. And they really, from yesterday's discussion, we realized that now we are able to prototype faster. This was a quote from the co-founder of LinkedIn. He said that if you aren't embarrassed by your first version of your product, then it means that you shipped a bit too late. So it means that the first version of the product that you want to bring to the market usually should not really embarrass you, but it will not be what people will be using when the product is fully matured. So there's a maturity phase of a product life cycle. That maturity phase is the point where the ideas that were scattered in your mind and they were not so organized becomes fully blown, and people are able to, relate to the product. So we are going to look at the journey. So an idea can be a small concept in your mind or written on paper or somewhere. And then we move from the idea to prototypes, a tangible version for feasibility tests, and then testing all the risk around it and all that. And then once you get your prototypes, how you're able to move this prototype to an MVP. So you hear MVP in the software engineering space very often, the minimum viable product that real-world users can actually use to solve real-world problems. And then once you get your MVP and then the product is already on the market, the user feedback and then user engagement that you have with the business, you're able to now add on features, year on year or month on month, depending on your release cycles. Okay. So, a prototype, an early working model of a product or a system. So the defense I witnessed, I saw a lot of prototypes, a lot of brilliant ideas that I would say some were done because of the timelines. They're supposed to finish and defend. So you see that it is the first working model. I'm sure if they give them another 2 weeks, they will come with something more improved. So usually it is built to test and validate the ideas that you have, the concept that you have, before you think of full-scale deployment. So the goal of this is to want to test your concept and then expose your concept to the possible risk of such product, and then it becomes a basis for decision-making. Investors or partners will see the idea and will be able to think about it as this thing, I can scale it, or this product won't sell. And not to say that once somebody tells you that your product won't sell, it won't sell. Sometimes they've not seen what you've seen. So if someone challenges your idea that it is not, there's no data, there's no history of data that is backed by this research work, so it will not, there's no demand. It is not a blocker. You can actually go back to the room and then look at it carefully, and you still have a conviction that it's an innovation. It has not been done before. You want to still push it. You can push it. So it can be electronic. So because of the department that we are working in, I'm just using a breadboard, electronic setup, or a quick application like a Python web application, Django-based application that you have deployed. Localhost or some vessel server deployment, test server. So that can be an example of a prototype. So how people stop at this stage? How people stop at this stage? There are some pitfalls of stopping at prototypes. Most of the prototypes we have here on campus or even outside, there are some reasons why they stop. Like people don't continue working on them again right after school. One, so they lack scalability. They lack scalability. So because it was done within, to test the concept, they didn't have the customer at the back of their mind during the design process. So if someone even has money today and wants to invest into those products, you realize that it is not market ready. So by design, it's not market ready. It lacks scalability. For the most part, there's a technical gap. I saw some of the works yesterday, and there are some working parts of the system that we are happy about. Some look very fancy, flashy, some look very nice, and the beauty of the interface gives us the impression that we've made it, we are going to sell, but it's not ready. There are elements that you need to optimize within the application. Optimization, you have to modularize the project, you have to think of deployment, how you are going to scale the numbers. So there are questions that technically there are gaps within the solution that you have done. So the scalability mindset now comes in. So after final year, you are done with your project and you want to scale. How should be your thinking process? there's two legs: technical scaling and then business scaling. So if you are a computer engineer and you don't know how to scale the business, some did some basic accounting economics as part of their course process, just to give you a fair idea that there's something called business. So if you cannot do it on your own, you look at strategic partners or friends from other departments who will help you with the business scaling. But when the business scaling is, say, ready, then your leg is to ensure that the system can scale technically. We are looking at the choices of the architecture. So there are enterprise-grade architecture that helps applications scale, either vertically or horizontally. So there are some questions that usually we ask. For instance, if the traffic doubles overnight, what will fail first? Oh, your app is very nice. It's so nice. It's actually, my roommates are using, they can all connect. Don't worry. If overnight the traffic doubles or triples or by, say, 10 times traffic that you don't expect, what will first fail? As engineers, you start thinking about those things. Can we deploy 5 times faster without introducing bugs? So thinking of scaling, people are already using the system and you want to introduce a new feature, then there will be downtimes before you introduce the new feature and to introduce bugs and all that. So you realize that you have not made the right choices in terms of technical scaling. So don't think of prototypes as, oh, once I get powerful computers and I put them there, it is ready to, no. There's a way you modularize your architecture to scale the product. So by modularizing the application design, you have components. So the main project is broken down into components or subsystems. So in a technical term, you can see we are making our system, say, microservices. So there's a main system with several microservices, which each service can scale. So assuming that microservice A is where the traffic is hitting, we are able to scale that microservice in real time so that the application can still handle the load. And these microservices should be able to scale independently. And by doing that, you are decoupling the system. So the system are loosely coupled. You don't tightly couple or bundle the application side that it is difficult to scale technically. I'll give examples and the tooling that we use to do those things. And then sometimes when you are trying to deploy some of these systems, cost becomes a critical element. So you are looking at cloud approach, and then once you get some more resources, you have a hybrid cloud with physical servers and then cloud servers, and then implement some kind of data synchronization between the two systems. And for most of the applications that we design, we are looking at having an API-first approach. So your system's core APIs should be available, well documented with, say, Swagger or any other documentation tooling, and then you make it available for consumers to consume. So for instance, you can use RESTful APIs or GraphQL. So there are different kind of APIs. Some actually use web services with like SOAP standards, XML data parsing, but depending on how you think people are going to consume your application, you make a very right choice for either GraphQL, you are going to use RESTful APIs, or you are going to use XML data exchange or data parsing. And then once your data is growing larger and larger, people start implementing some kind of data partitioning or data sharding, where we subset our data into, we break down our data or database into several data subsets. And some traffic sources, let's say customer 1 to customer 10,000, are going to connect or query from this data subset. Customer 10,000 to customer 100,000 are going to connect to this like this. And then we should have a way of synchronizing the data. So, and then also you have implement replicas of your database. So these are technical scaling ideas, how we scale our application technically. So at another leg, we are looking at performance planning. Performance planning is from day one. Once you get to prototype stage and you want to move from prototype stage to real-world product, one of the things you're supposed to think about every day as an engineer is performance. You plan performance, doing a load test from day one. So you don't wait for real-world traffic before you know how a system is going to respond to the traffic. You can simulate the traffic. And then implement some kind of caching strategies to cache data in memory, such that when people need those kind of data, it's available in memory before you are looking at data stored at rest in the database. I will talk about some of the tools that you need to implement caching. Then asynchronous processing of large tasks. So for multi-thread and single-thread applications, usually some of the activities lock lock the main thread, and it prevents other users from having access to the system. So we are looking at having some background jobs running. So once the job is more than a particular, let's say, threshold, or it's going to take much more time to process, image process, video processing, large data batching and all that, you move it to the background, and then there's an asynchronous background processing. And then for query optimization, we are looking at indexing your data so that it's easy to access and you're able to load the data faster. So in the performance planning, we are still looking at one, monitoring. So we're having Grafana dashboard, data docs and all that to track the system's health check. So technically speaking, you would have an application running and another application monitoring the application running to see whether all components are running and they are in good health state. And then you also want the application that is running to give you insights for scalability or for scaling systems. You want to know which part of your application are people interacting with the most. So you send analytics to, say, Google Analytics, App Insight, or Mixpanel, and this feedback will tell you which part of the application is mostly used. So if you are using my system, I know that most customers are using the ordering part, or they are using the payment part, or they are not using this feature, or it's difficult to interact with this particular feature. So in the deployment and code and deployment practices, at scale, we are looking at continuous integration, continuous deployment, CI/CD pipelines. That's, so developers, we work, for instance, with, say, GitLab. So in your local environment, you collaborate with teams, then you push to your branch. If the branch feature is complete, you make a merge request or a pull request. Then they check out your branch, test if it's working, then it moves to the develop branch. Then the developers will look at the develop branch and then all the features there. Once everything is fine, it's moved to the QA environment. The QA tool will test Then from the QA environment, they move it towards, let's say, the prod environment. And all these things happen in an orchestration or a pipeline. We don't do it manually. So there are checks that we put in place on the cloud infrastructure to handle all these stages. So if you have even 100 developers or 200 contributors, we are able to manage the input from each developer, and then by merging and then pushing to different parts of the application, we are able to ship to prod. And then even if we get the data to prod or the update to prod and there's an issue, we should be able to roll back to the last stable build. So this is how you start thinking when you are looking at scaling your prototypes. So coding and then deployment best practice. So they are all automated, like automate testing and deployment and release update and all that. Okay. And then process scalability. So if you find yourself with a startup and then you want to have some ethics, you need to have coding standards. So in our team, there are ways we write our commit messages, there are ways we create our branches, and it's a standard. So you should scale that thought too as well. Everybody does things in a particular way, so that we're able to get more engineers join our team, and then it's well documented on Confluence. You see our standards, and then you follow. So there's a standard operating procedure for software engineers, and how we write our code, how we document our code, how we shape our code. So if you want to scale your prototypes, we optimize our code. We make sure that our code is clean. For us, we use clean architecture, and then we collaborate. And so another thing to scale your product is delegation. So as engineers, sometimes when we have our own product coming up, we are afraid to work with teams. Somebody will steal my idea, somebody will steal my idea. No. Put the teams together, delegate more, and get more people contributing to the project. And then you realize that technically the code base is optimized and it scales faster. Okay. So I've spoken more about the technical bit. So for the business scaling, we are looking at also a scaling process in the business part of this. So if you have your business tool running as a startup, you should also establish the same SOPs for the business. You might not understand. Your co-founder or your partners who are from the business school will tell you more about it, that there's a way to have a business plan, and then there's also a business model. Then they'll give you the financials, the forecast, the revenue forecast, and even pricing, marketing and sales strategy to get your product to the market. That one is a different part of the whole scaling process. There's a go-to-market strategy. Different products will have different strategies. You saw some of the products, they have their brand presence over here. So the technical guys wrote the code, and then the business guys give us a brand. And there's a way to do it. If you don't do it well, you can have an excellent product, but people will not buy into the idea because you have no idea how to move the product to the market. So once you are done scaling technically, somebody should help you scale the product to the masses with very good business models and business strategies. So at that point, you are looking at how much it's going to cost to have a unit sale of your product. So some of the engineers that I know, or how we do our stuff, because we write the code ourselves, we don't even quantify, we are unable to quantify the effort that went into it. Oh, this one, I didn't buy anything, it's just my laptop. No, the time you use to work. So at Heidelberg, our rates are hourly. So if there's a project and there's a demand, we are able to look at the man hours. Okay, we will need 20% of Philip on this project. We will need 70% of Eric on this project, of that. And then we're able to create a cost budget, the cost of producing that application within the time frame. But I realize that when you are in school and you are building this, we don't put cost on it. So you don't even know how it costs, how your product costs. You can just offer, mention some money. You think you have mentioned big money, but you've not mentioned anything. So the finance guys will help you in costing. So with Jira and all those things, you're able to log your activities on the project, like a work breakdown structure. You log each activity and know and put weight on the activities that you are doing. And once you're able to put the weight on the activities that you are doing, we are able to also know amount of the budget we spent and what we have available. Because the more you work, the more the budget allocation, the spendings are deducted from the work done so far. So that when you miss your deadlines, there's a cost overrun. Then you see that we have reached our budget or exceeded our budget. So you have to get more budget to work with, or stop the product, or prevent project creeping, changing the scope, and every time changing the scope. So you exceed our budget. So when you are scaling you are thinking of budgeting and making the product clear. So business and funding considerations. So the business guys on your team will help you choose some of the monetization strategy. I put some there. And then make sure that if they ask you a very simple question like, how much do you need to scale this product? You don't say, I'm going to think about it. You should be ready to tell an investor to take, I will need X amount of money to move my product from prototype to scale. We don't do that. We don't have that idea. And once you are not confident about those things, the investors, they pull back. Or if you are lucky, they want to help you get it. But we should be able to tell us how much it will cost you to move your product from a prototype to scale. And then some of the things that we try to build ourselves at scale, from yesterday's presentation from the keynote speaker, you realize that you don't have to build everything yourself. You should have your core business and then integrate with as many systems as possible. Email service providers, SMS service providers, hosting service providers, payment service providers, different providers working together with your core system. And you scale faster. You scale faster because they have mastered that part of your application as what they do every day. So instead of you thinking of how you are handling emails, somebody is doing that as his main work. You factor the cost in your cost, and then you're able to price properly so that it doesn't become a burden for you. So the interplay between the technical scalability and then the business scalability is actually what will make your product scale. If you scale one side and you don't scale the other side, you fail. If you scale one side and you don't scale the other side. So there are some businesses that, there's a product I have on the market that one of my competitors has a larger market share, I'll say. And because the market share is very big, they are getting big customers. But they are losing the customers because of a very small challenge they are unable to fix. I'm winning the customers, but it's paining me. Because they've scaled their business, but they've not scaled technically. And they don't know what to do. They have the money, they have everything, but they don't know what to do next. Me too, I won't show them. So that's the business. You have to scale business-wise and scale technically. So there's a technical glitch they are unable to solve. And people want to pay more for the fix, but they can't fix it. I don't know why. It looks easy, but they can't fix it. So, challenges in scaling, like I mentioned before, performance bottlenecks, security vulnerabilities. When you are having your application and you don't have money and it's a small business, hackers and third parties are not going to disturb you. Once they hear that, ACs have an app that can do this and is getting $1 million overnight, then someone say, let me come and test this thing and see whether I can get something from them. Then they will start disturbing you. So if you don't have at the back of your mind security, you get all the money and then you lose all the money. You get all the money, you lose all the money. Or you get all the traffic, and before you see, data you think you have stored in your database is somebody will send you an email of your own data, that you see this data, it is from your database. If you don't give me this, I'll do this tomorrow, I'll do that. Before you see, your application is down. So security is very important, performance is very important at scale. And this form part of the system's integrity, how people will trust your system. People must trust your system that, no, my data sitting with these people is safe and reliable. And then non-technical scaling is about market changes. The market will always respond. So if you bring a product to the market and somebody sees that, oh yeah, your product is good, but you're not scaling it properly, people with enough resources can come and compete with you, and then the dynamics of the market will change, and you also have to respond to the change. So don't think that somebody has stolen my idea until maybe you've patented the idea and nobody can use it. But once you've not done all that, it means that be ready to compete in the market you are operating in. So if you bring a product and somebody wants to compete with you, maybe it's fair. So you have to always look at your product and find how the market is changing. The demands of people keep changing every day. So you keep going back to the customers for feedback, for reviews, and then keep enhancing your system. And then promise them updates as they want, and then make sure that your system is meeting their demands. That one, you still be in business. Otherwise, you scale and not be in business. Then team capacity limitations. Once you are scaling and you think everything is all good, some of your very good engineers will leave you. They will leave your team. I've gotten an offer from Microsoft. He's gone. So if you don't document your process and document your systems and document your stuff, once they go, there will be a technical gap that you cannot bridge, and that will be the end of your product. So document your systems. If you see potential in any product, have scaling in mind right from the beginning. All the codes must be committed to the repositories. Changes must be logged. Release notes must be documented. Features must be documented. Everything about the product, so that if somebody leaves and another engineer takes over, it's easier for the onboarding. Then you are thinking of scaling. It's on your laptop. Everything's on your laptop. Nobody should see my code. If you see my code, you copy it. No, you are not thinking of scalability. Don't think that way. Okay. And I've mentioned this before. So some of the applications need to be, the deployment should be segregated per region, regional basis. So some applications, if you're not in Ghana, you can't have access to it. And then also some of your applications, if you are scaling, you should think of regulations and compliance. Your applications to comply with some of the standards that engineers follow, and even legal requirements. You can't just ship anything out there that you are doing business. There are legal requirements for different business sectors, and if you don't have the knowledge, seek counsel from a legal person or a member of your team who has legal background, and then advise you on what to put, what features should be there and what should not be there. The terms and conditions and privacy policy and those things, most of you go and copy from some site and come and paste and use. It's not like that. You don't copy somebody's terms and conditions and use as your terms and conditions. If there are issues, they will reference you to those things, and then you realize that you didn't understand what you were doing. So in scaling, the legal leg should also be left out. You should scale that part to get someone on the team who will stand with the product to scale and understand all the legal demands of the product you are bringing to the market, and make sure that when any issue comes up, they are ready to talk for the brand or speak for the brand. The same thing for your finance people, your accountant, your tax consultant. They all help you with the scaling. So it's a very tricky thing here, business scaling and technical scaling. So I think we have a lot of speakers, so I'll just bring mine to an end here and then we're waiting for questions. Thank you.
Thank you very much, Thank you very much, Mr. Philip Kwenu, for guiding us on how scaling can be done. So here's one thing that I wrote down that I'm going to take note. He made mention of us when we build our teams, we should document our code, or we should document the structures that we put in place. So whenever there's a technical gap where an engineer falls out of the team, when someone comes back in or we hire new engineers, they can understand the way the code is being written, or the way we create branches, or the way we do our pipelines, and then work out from that. Thank you very much. So to our next speaker. Our next speaker is the founder and chief executive officer of ABZ Automations, which is a pioneering company delivering cutting-edge water system automation and control systems. The speaker is a graduate of aerospace engineering from Kwame Nkrumah University of Science and Technology, the class of 2020. The speaker blends a deep technical expertise with a visionary approach to problem solving. His academic foundation in complex systems and engineering principles fuels this passion for creating intelligent solutions that sit at the intersection of software and hardware. This bridges digital control with physical automation. Our next speaker is Mr. Abdullah Mohammed Zainuddin.
Good morning. I am Abdullah Mohammed Zainuddin, founder and CEO of ABZ Automations. ABZ Automations is a startup which seeks to eliminate manual and repetitive tasks through the development of hardware and software integrated solutions. Our flagship product is an automatic water pump controller. Basically, what our product does is it prevents tanks from overflow, and when tanks run low on water, it automatically pumps water into the tank. And in addition to these functions, it protects the water pumps from damages that are caused either by the pump running dry, i.e. the pump is running but not pulling any water, or damages caused by power surges. And I've been told that currently the washroom is not in service because the water pump is damaged. So I was telling myself, had this building been automated, i.e. the water pump in this building, this issue probably wouldn't have occurred. So I don't have any PowerPoints. It's just going to be a discussion, a very, very short one. I want to use my journey as a case study. How do you move from prototype to a viable product or a scalable product? I started this in 2018 when I was still a student here. We're in third year then, I think. And one may ask, where did I get this idea from? Once I was having a discussion with my auntie, and she narrated a challenge that she faces day in, day out in the house. She mentioned that once she left the house going to work. She stays, for those of us who know Kumasi, she stays at Kinyase. After Asokore Mampon, there is a town there called Kinyase. That's where she stays. And she works in town at Edum. She has a shop there. She got up very early, prepared for work, left the house as early as 6 so she could get there and open the shop to start business. She got to the shop. Just when she had finished setting up the place, hoping to get some clientele that very morning, she received a call from a neighbor telling her that the water tank in their house is overflowing, and there was no one in the house to turn it off. So she had to leave the shop, go back to Kenyase just to turn off a switch. And before she got back, It was past 9 a.m. in the morning. So when I heard this ordeal that she had to go through, it sparked an interest in me. I've come to the school, to KNUST, to read engineering. Can't I put together something which would solve this problem for her? And then, as if not enough, in the same house I was staying, one day we were there at night and we heard a loud sound. We rushed out to check, and it was our poly tank together with the tank stand that had fallen over. And this wasn't a metallic stand as you see around. This was a concrete stand, and it had fallen over. Later we understood the reason was that due to the constant overflow of water, the structure, the integrity of the structure had been affected and it couldn't hold on anymore. And that was the reason it fell. Actually, for those of us who may be aware, underground water is on the acidic side of the pH scale. So when you have it constantly overflowing and running over your building, after a while, it deteriorates the integrity of your building. So these two challenges form the backbone to this innovation that I took upon myself to start and then try to address this challenge. So 2018, I started. And aerospace engineering, every summer break, we go to the Ghana Air Force. That is where we have our industrial attachment. So it so happened that we've been actually taught how to design circuit boards, from using the CAD software to building it yourself. So we've been actually taught how to do this. Initially, I thought it was rocket science, but after we went through this training, I realized, no, this is something that I can build myself. So I went online. I was searching for a very good source where I can learn about basic electronics. And I found a book which they call, the Dummy series, right? That was where I started from, Electronics for Dummies. And I spent all day, all night practicing on basic electronics from what we've been taught. And it's funny that when I was in school, I was taught basic electronics. We had some lab sessions, but as most students, we didn't take it serious. We're like, aerospace engineer, I'm going to end up in the aircraft. What do I need this basic electronics for? We didn't understand why it was part of our curriculum. And there was a time through my journey that I really had to go back to the slide that my professor, I think he's here with us at the back, Dr. Selom Klogu, the slide that he used to teach us. I had to revisit the slide to understand something so I can apply it in my project. So I started, like I said, 2018 with the prototyping. I was using this Arduino board, as we all know. I was connecting the connectors directly to the pin headers. I was just writing the code, upload, test, and running the test and everything. And after I had a product that I would say, oh, this is something that I can take to the market. Now, the challenge was moving it from the breadboard to a real-world product. That was where I had the challenge. When you are building on a breadboard, typically you power your circuit from DC batteries, right? Or you just plug it into the outlet of your laptop, right? The USB outlet, and you power it. Now, when I go to fix it for homes, how do I power my system? And finding solution to this took me 9 months. I tried all means I knew, and it wasn't working. Until I spoke to someone that this is a challenge I'm facing, I'm looking for a solution. And he gave an advice that, why don't you build your own power supply? And that was when I revisited the slides that we used in basic electronics. You remember the rectifier circuit, right? That was when I revisited the slides, and I took some inspiration from that. And after 9 long months, I finally had my own power supply to power my units. And talking about all these, mind you, when I went for my very first installation, my power supply, I didn't have anything to package the power supply, so I had to place it in a fan ice box. You know, when you buy this fan ice, which comes in this small box, I had to put everything in that and make some holes, and that was how I packaged it. At least I needed to get moving. I needed to start something. So I made my very first installation in 2020 March, just before the Corona lockdown. That was when I had my very first installation, and there were lots of frustrations. In fact, at a point, I almost gave up. Every now and then, the person will call you, "Hey, Charlie, then you go, you try to fix it." And I remember the person we installed it for was actually a family friend. There was once a time that we went to the house, and his mother made a remark, which when I remember, it's always interesting. She said, because she was seeing us for about a year. Every single day, almost every single day, we are in the house trying to fix something. And things went on like that for a while. And I'm someone who has this can-do spirit. I never give up. So I was trying to find ways of perfecting the product. And it wasn't until I came across a partner that I now have who is in Pakistan. I was online searching for people with experience in electronics, and this guy agreed to partner with me because he was doing something similar. That was when he taught me some of the challenges that he also had when he started, and I was able to solve most of the problems that I had, especially with my sensor readings. So he introduced me to a different type of sensor. I started using the ultrasonic sensors that we know, right? That was what I was also using. And it was always giving me problems. I tried the waterproof ultrasonic sensor. It was giving me problems. But when I met him and I spoke to him, and he directed me to a different type of sensor, and I used that, and up to date we still use that type of sensor, and we have no issues with that. So there are a lot of pitfalls, frustrations, setback, but as long as you don't give up, trust me, one day you will make it. So once I decided to just leave up this project and start something else, because the frustrations and the lack of sleep was just too much for me to handle. And I took on a different project. 3 days into that project, I said to myself, Charlie, nowhere easy, because I was facing similar challenges in that one. So I had to come back to this because I believe that one had bigger potential than the other one that I was subsequently working on. So I tell you all, never quit. It is possible. Whatever you're doing, and you believe, as long as you believe in that thing you're doing, trust me, one day there will be that breakthrough that you are looking for. We started with analog circuits, and as I speak to you now, all our systems use digital circuits. So the circuit design that you've been taught, don't play with them. You will need them one day, because all my circuits, I build them myself. I design. So initially, after designing, I'll go through the process of etching the boards, right? Then soldering the components and everything. But then as the business started growing, I realized this is not going to help me, because in a day, how many can I produce? So I started looking for ways of speeding up my production. That was when I thought of, okay, what if I design the circuit myself, then send the design to companies outside for them to produce the circuit for me. So I did that, and then now our production took a pace. From 20 in a month, now we're able to make about 50 in a month. And then as the business kept on growing, I realized even that is not going to help us, because after they are done building the circuits, we have to come and sit down and do the manual soldering ourselves. So now, instead of just building the circuit board, now I would send the design and the bill of materials and everything, and they will build the board, and they will do the assembly of the boards as well. So now, before the boards will come, it's just left for you to what? Do the final assembly of the product, and it's ready for the market. And as I speak to you now, we've made over 500 installations across Ghana. And some of our installations can be found on this very campus. And I tell you, when I started, I just wanted to solve the problem of what? Tanks. I don't want the tanks to overflow, and I don't want the tanks to run empty. But now, as I talk to you, the products, we've added features that through this work we've identified to be challenges that are faced by our client. For example, for most people, after they dig their borehole, you realize that after pumping the water for about 20 minutes, there's no water coming from the borehole again. So you need to wait for about an hour or 2 hours before the water in the borehole will yield again. So we added a feature which protects the pump. So whenever it is running and it detects that there is no water running through the pump, off. Otherwise, it is going to overheat and eventually burn out. And in addition, some houses or households have this issue of, over voltage and under voltage. Yes, what our people call over high currents and low current, right? So we also thought of adding this feature to the product, because if you, for instance, if you look at our product as it is now, previously people used to combine at least 5 different products to achieve something close to what our product does. But now you need only one at the fraction of the others, and it will do all these things for you. So as you go along the way, you talk to clients, you ask them the challenges that they face. What you see as a challenge may not be a challenge to your client, and you design a product and no one is willing to buy. So you talk to them, you ask them questions, and never be afraid of any challenge. When I started, my system was only for single-phase water pumps. But I'll be there and someone will call me, "Can you automate a 3-phase water pump for me?" I have no idea, but I'll tell the person yes. And the person will be like, "What is the price?" And I'll be like, "I'll get back to you." And now I'll go back to the drawing board. I'll look for ways of doing it. Okay, you go online, you learn how do 3-phase pumps work, how do you automate it, how do I connect it to my system. And through that, now I'm able to control 3-phase pumps. And then also, you'll be there sometime, someone will call you, "I'm into pure water manufacturing. I want you to automate my water treatment plant for me." You go there, and then you see 2 pumps, 3-phase pumps. There is this thing, there is this thing, there is a tank here, there is something that looks like a tank. You don't even understand the system. But I take it upon myself that I'll solve your problem for you. And now we automate water treatment plants. So never give up, and don't be afraid of taking on challenges. There is always a solution. There is always a solution to all challenges that your clients may face. So I think this is the little that I have to share, and we'll meet during the question time. Thank you very much.
Thank you very much, Mr. Abdullah. So one thing I learned from Mr. Abdullah was when he made mention of, as you scale a product, you have to learn more on how to add a product. And this takes me back to biomedical engineering design, where every product there's an iterative step. And so as you add extra features to the product, you learn that by speaking to the clients or the customers, those who buy your product. And then when you hear their concerns, you're able to ship them a product that they need, instead of just assuming for the client or the customer there are problems. So our third speaker for this plenary session. So yesterday I had a chance to see one of his products outside, and I should say I was really amazed. So our next speaker is a fusion thinker and an AI design strategist. He advances healthcare equity in Africa through ethical, human-centered innovation. As the co-founder of Axel MD, he leverages AI to transform preventive care, early detection, and health engagement through literacy, lifestyle insights, and visual intelligence. The speaker leads multidisciplinary teams at IDS, Dream Brander, Walter 7, and creating a stable Africa-first solutions at the intersection of design, diagnostics, and behavioral change. His work explores how AI can be shaped by design, data, and spiritual intelligence to drive impact in health and education. Our next speaker is Mr. Samni Ajado.
All right, I'm excited to be here this morning. I want us to have a short discussion. Is my presentation on? If you can help me with that. So, one of the key things that I've learned as a business developer is to study. I think that people who build businesses are great learners. And as we are learning how to scale products, we need to understand the things that we're supposed to learn about. And one key thing that I believe when our brother was sharing his idea that I want us to start with is long-term thinking. Long-term thinking. So you can look at your phone. Let's pick our phones up. I just want you to practicalize something. I want to show you something. So take your phone and then think about it this way. Immediately you pick your phone, one of the key apps you would want to open, it's WhatsApp. It's as if it's been built into your system. That you pick up your phone, even when you wake up, is to check your WhatsApp. And then so Meta is doing well when it comes to this artificial intelligence era because they have developed a solution that is not only scaled in its essence, but gives them the opportunity to scale a lot of the solutions they bring. And the fundamental law they are obeying is that they are thinking long term. So we are supposed to design tomorrow. Tomorrow is 13th. How do we design tomorrow? How do we prepare ourselves for tomorrow, for future? So if you're going to actually develop a product, a prototype, and to send it into something that is scalable, one of the key challenges that you will need to face, which will afford you the opportunity to be patient in your developmental processes, is that you need to think long term. Are you willing to take that your prototype? How many of you have business ideas with your project work? If you are here, students, and you think you want to develop a business from the project you did, let me see your hand up. Really? Yes. Now think about it. Are you going to go ahead with it if your project will succeed 15 years from now, 20 years from now? That is the first question I want us to be asking. Am I able to do this thing for life? Am I able to do this thing for life? Can you go to the first slide for me? First. The first slide. Go back. Go. Yes, to this. Now, we are developing product to scale.
Hello?
The purpose is to develop products that would scale. Now, when you think about the future, it's very fascinating what the future is. The reality is that when we talk about the future, the core factor that we don't really look into is the fact that the future cannot be without human beings. We cannot talk about the future without human beings. It's a very core thing that we have to be thinking about as business people, as people that are trying to develop solutions and scaling them. Human beings are at the center of not just thinking about the idea, but making sure the idea becomes viable and that it will last for a longer time. Human beings are the factor that not only your product will be something that is desirable, but people will be willing to pay. So without people paying for your product, you won't be able to scale. Without partners joining you to make sure that you have what you require to scale the product, you will not be able to scale. So I want us to look at the things that we should be thinking about. Should we want to convert prototypes into scalable products? I said we should think long term, but the fundamental thing that when we talk about the future, we cannot forget about is the person by you. The person by you. So when we talk about the future, we're talking about people. Nothing else. If we were talking about the future of Tweek yesterday, without you sitting here this morning, Tweek will not be happening. So the future of your product is the person that will be using the product. You have to think about the person. It's critical. I mean, you've gone through the technical presentation. Our brother also explained his life story, but I want us to be thinking about the factors. You have to be thinking long term. You have to be thinking long term, and you have to always think about the future as a person, and not just the seconds that are moving. There is a person that you are working for. Will the person be there? Will you get someone to partner with you? Will you get someone to pay for your product? Next slide, please. Now, when we talk about scaling, what we forget about products is that products that scale are not just intangibles. Because we are talking about people, what scales when it comes to people is the purpose of a thing. The purpose of a thing, the meaning that we create is what scales. So if I'm using WhatsApp, why is WhatsApp scaled? Why is a product going to scale? It's because of the meaning of that product, the purpose of that product. So as humans, we like to connect, and the way we connect is to communicate. So WhatsApp, YouTube, all these products that are scaled are trying to create meaning for people. So there has to be a purpose if you would want to convert your prototype into a scalable solution. Purpose is critical. So you should think long term. You have to think about people, and you need to think about the meaning you would want to create for people. Next slide, please. This is what scaling is about. This is what scaling is about. Do I have the resource to scale? Do I have the people to give me the resource to scale. So we cannot be talking about scaling prototypes without cash. Without cash. So I worked on some project with multinational companies, especially in the health sector. So I was working with Johnson & Johnson as a designer, and I realized that majority of the solutions I was giving to Johnson & Johnson, even though they were printing them, they were traveling to other parts of the world. So I would do the designs in Ghana, and then it will be shipped to US, it will be shipped to Europe, it will be shipped to Saudi Arabia, and then they will convert what we've done in Ghana into other languages for people to use. So this taught me something. One way or the other, by doing this, we also got the opportunity to work on a project of developing presentation stuff, communication stuff, for them to actually scale a solution, a product that they had come about. So they gave us resource for doing that work. And I asked myself, because of technology, very soon printing will have some challenges. So why don't I think about the future of what we are doing for Johnson & Johnson? Because people are asking for the solution. So what do? We have to convert what we are doing on a smaller scale, which is printing, to the place where we can put the solution in a lot of people's hands. So let's digitalize it. So I spent $100,000 that I got from the resource to set up, so that being a designer, we can bring on technical people like you, so that we can convert the solution into a digital solution. You will need resource to scale. Without money, there will be a challenge. But there are several methodologies, several strategies to actually get resource. And you need to think about that. So you have to be thinking long term, you have to be thinking about the people, you have to actually be thinking about the meaning, and you need to think about resource. Next slide, please. From here going, we have to be fast. So I've spoken to you about people, I've spoken to you about long term, I've spoken to you about resource, and I've spoken to you about meaning. The whole idea is not just about looking at something big. The whole idea about scaling is to look at the small thing that you are doing and think about how that small thing can be repeated. You have to look at the small thing that you are trying to develop and get to see how that small thing can be repeated. So scaling is about repetition. So it looks very small, like a seed. So if we want to have a lot of trees, what we have to ask is, how many seeds do we put in the ground so that we'll have a forest? You need to put that small seed plenty times in the soil so you can have your forest. So it's repetition of small steps. Scaling is about repeating small steps. If somebody is giving you $1, how many people should give me $1 million? It means that I should be able to give this thing to 1 million people to give me $1 million. So the whole idea that I learned from business development and entering this form of creating a solution is that I need to get a small problem, solve it, and repeat it for a lot of people to use. So the seed is very small, but is it really small? Next slide. Is it really small? An egg. You know that all the eggs you are eating in Ghana could come from an egg, because an egg will give birth to that, a chick. So one single egg can replicate itself. It will scale for a lot of people to use. So that mentality of that small thing you hold in your hand, how do you repeat it? How do you translate it? How do you transform it to a place where people are using that, your solution? Next slide, please. It's a simple thing. Look at it. Think about the millions of transactions that are happening as I'm talking to you. You're on campus. I was surprised that, people are paying transportation, trotro fares with Momo. So imagine 5 Ghana cedis moving in daily by millions of people. It's just a simple transaction. I want to pay, you want to receive money, and you are using phones, let me transfer money to you. But we should do it, we should design it so that a lot of people can use the solution. So look at Momo. Daily transactions, daily decisions. You can't do without it. Next slide. This is a beautiful thing for startups when we get to see the numbers. So I saw this news item 3 years ago, and I was like, wow, because I saw them when we started. I think if you remember, those of you engineering lecturers, there was Tech Hub, and then under the Vodafone Cafe, we used to come there, and that's where I was learning. And I saw these people, farmer line, 2 guys trying to develop a solution. It was a very basic solution. Just use USSD and then help farmers, help 300 farmers. Let's move to 1,000 farmers. So how do you get to the place where now money can be pushed into your system? Human beings are very complex. We don't need complex stuff. So when we are talking about scaling, we are talking about, please can you move to the next slide? We are talking about simple stuff. Look at TransFlow. You can look at it. TransFlow. Yesterday, the IT consortium businessman was talking about it. Simple stuff. Make it simple if you want to scale. Very basic, very simple, not complex. Simple, because what a human being is paying for is the fact that that which is complex has been made simple. Next slide. So how do we simplify things? Localizing the solution. If you want to scale, you have to localize it. Again, I will use Facebook. So Mark Zuckerberg is trying to create a solution and says, I will not be going for lectures. I will develop this thing so that my friends on campus will use. And then he is tempted by another group of people with money that start this business with us. He comes and he sees what he is developing is what these investors are trying to poach him to do for them. So he rejects the offer of being paid some amount of money to develop something that just his mere colleagues will use. That's Facebook. That's Facebook. So how did Facebook get to where all of us started using? Localizing the solution. Localizing the solution. Making sure that your solution is used by the people around you. Because if you're going to solve the problem, you need to make sure that you are testing it by the people around you. So you have to first localize what you seek to scale. Yesterday, I was in one of the defense, and we asked a very simple question. So you are doing this, but what if this thing happens according to how Ghanaians behave? And that was a challenge. So if you are able to localize your solution to solve the demands of the people that are using your solution, human beings are similar. We are the same in different shapes and colors. If I'm able to solve it for you, there is a higher chance it will help another person. So you need to localize the solution if you're going to scale. If you're going to scale, you need to partner. I like to read, I like to research, but I believe that there are better researchers more than me. So what I have to do is to partner with researchers. I know that people have the resource and are willing to give the resource for good things to happen. So I need to partner with those with the resource. You need to also partner with authorities. Your solution is not going anywhere if it doesn't meet compliance, if it doesn't meet the demands of regulations. So you need to have these ideologies going on in your mind as you are prototyping. So the prototype, even though it's small, if it is going to scale, it has to be put in that small thing. If when you pick the small thing, it cannot be multiplied to be 2, you can't take it to 100,000. And without these authorities, you cannot push what you want to push. If your solution is working and then Ghana Standard Board says, hey, no, we are not allowing this, it means your solution is not going to be in the hands of Ghanaians. So you need to think about partnership. And the partnership is not just even on this higher level, especially because you're going to be beginners. You have to look at the guy by you and realize that the person has something you don't have. And if you're going to scale, you need what the person has. Basic, simple stuff. I need you to push this solution. The person needs you to push his solution. So do we come together to push this solution? That is how to scale. Without partnership, you cannot scale. It's impossible to scale. Let me give you this simple analogy. A male cannot give birth. I want you to practically think about this partnership I'm talking about. A male cannot give birth. A female cannot give birth on their own, individually. So to give birth, to multiply themselves, they have to come together. So if we are talking about scaling, partnership is critical. So mind you, all the things that I spoke about, long-term, people, cash, meaning, every single thing I'm talking to you about, all of these things are supposed to be part. So if you're going to partner, look at the person. If you're going to partner, look at the meaning. If you're going to partner, look at the resource that will be needed. If you're going to partner, look at how you're going to partner for long term. That is how to scale. Next slide. I want you to think about something. Now that I've spoken to you about all these things, practically, let's look at this. What are you on? Currently, what are you on? Oh, I want your response. What are you on? Do you know the number of times you sit on a chair? Think about it. So far as we are human beings, we are going to sit. It's basic, simple. Do you know how sitting impacts your health? Sitting. Do you know how it impacts your health? So if you're not sitting well, it is impacting your health. How do we give this knowledge to people so that people can now begin to sit well? It's very basic. This is not the only place people are sitting. Globally, a lot of people are sitting down. People are moving. People are eating. People are sleeping. So the daily choices, the daily activities is what we should be prototyping. And the more you factor into the daily choices, the more you have the opportunity to scale. If your prototype is not going to solve a problem on a daily basis, a weekly basis, or monthly basis, scaling will be a challenge. So at LMD, we're trying to solve daily solutions. And one of the key things we're trying to solve is to inform and empower people to know how their daily activities impact their health so they can change the way they behave. And that's basic. Everybody is doing it. You are doing it as I'm talking to you. You are seated. And if you're not sitting properly, your health is in danger. Next slide. So that's the application. Very basic application. But because it answers the question of long term, the question of future, because future, tomorrow is long term, because human beings will continue to sit, future, this solution can travel with a human being long term. It will travel with a human being long term. And so by coming up with this solution, what do? We need to partner, we need to serve it. Next slide. Next slide for me quickly. I'm about ending. Now, let's think about it. I'm sure so far as you are engineers, you are the people going to cook the food. Basically. If I'm a designer and I'm coming with an idea, I'll eventually give it to you. So maybe I'll have the ingredients, give it to you, you cook. But think about it. Do we cook food to store in the fridge, or we cook food to serve so that people will eat? So your main concern of scaling a product is how the product is served. And the way the product will be served must be factored into cooking it. So designing prototypes that will scale means that we must partner with the people we are going to cook for and then design, reverse engineer the prototype. Now, prototyping is learning. And every single step in the journey of a scaled product is a learning journey. So your daily activities, your daily steps that you'll be having is learning how best to serve the product. That is how to scale a product. How do I serve this prototype? Why do I want to serve it? This is what I want you to think about. Think about people, because people are going to eat the food, your product, use it. They are going to pay you. They are going to be there for a long time. So think about these three things. Thank you very much.
Thank you very much, Mr. Samni Ajado. So basically what I learned from him was that I took one simple sentence and it meant scaling means repeating small, simple steps. That means you start with something basic and then you work on it from there. Now we are moving to a series of questions and answers. But before I ask you to come up with your questions, to come and stand here and then ask your questions, I would like to invite two other individuals or two men to come and join them so that they can help answer your questions. So the first person that we invite is Mr. Bernard Janikowski. He's the managing director at Fort IR. And the second person is Dr. Bright Akua. He's a lecturer at the Department of Computer Engineering. So now, please, if you have a question, you can kindly come in front and then ask your question. We'd like to ask, if you have questions, kindly ask before we start our panel discussion. Yes, please. So you introduce yourself and then you ask your question.
Yeah, hello. My name is Joe Boynovis. I'm a final year computer engineering student. And my question is to the software engineer at Heidelberg. So, during your talk, you made mention of when you ship and your product is better, that means you shipped way too late. And then you also spoke about the fact that when building, we should ask ourselves, what if the traffic doubles twice? How will my system respond to that? Now, trying to ship early and then making sure you introduce the microservice you spoke about, which brings about a whole lot of complexities. How do you tackle complexities while making sure you are really shipping at a faster rate? And my next question is, you are a software engineer. There's been so much talks online about the fact that very soon, software engineers will be replaced by AI. Personally, what's your opinion on that? Thank you.
Okay, so thanks for the question. So with the development life cycle, the earlier submission was about when you ship your prototype too late, not your large-scale product fully blown. So I began with idea and then prototyping. So that the submission was your prototype should come out really fast. You don't spend so much time prototyping because most of the working systems from prototypes, usually they rewrite almost every code base. They rewrite everything. Because if I use AI, for instance, to generate a scaffold or a concept, and I want to scale it, and I mean there's funding and everything, we don't want to risk by saying that we are just carrying that code base to prod. We have to go through, optimize, restructure, do all those things. So that one will take time. And the time, with experienced engineers, you should be able to know the timelines for the go live. But if you ship too fast, it was in relation to the prototypes. And then the AI will take our jobs. But you're using AI, has it taken your job? Yesterday, we saw that AI is here to help us. There are tools. And then software engineering is getting really tricky here. It's like there's no hope because what you want to do, AI can do it better. But there's still a need for a human being to do something. Maybe we've not discovered it, but there will be something that the humans will do. Worst case, we'll manage the system with the people. Yeah, once they deploy, we are going to be with the people. So I mean, but AI will not replace human. For me, I don't think AI will replace me. I don't think so. Thank you.
Thank you very much. So because of time, we will not take any other questions, but when it's time to network, you can see any of them and then kindly ask them questions. So we are moving straight into our panel discussion. So I would ask a series of questions, probably only 3, and I would like to receive your answers. So my first question will be setting priorities in scaling your business. So I noticed that some of the speakers did quite make mention of scaling. When it comes to scaling your business, you have to have a basic idea. Some too also made mention of having like a set laid out goal, but sometimes the basic prototype, it's hard for people who are just entering into the industry or entering into the market space to know what to scale. So as experienced people in the industry, what are some of the priorities that maybe an individual who should set when they are scaling their product? I'll start with Mr. Philip.
Okay, so I think my slide says, scaling, referencing his slide, people. So at large scale, your target audience, what is the expected usage? Are you expecting millions of people to your system, hundreds of thousands, tens of thousands? At what rate is your data going to be growing? If you have this at the back of your mind, it will inform the architecture. It will just inform you know, and you see, if you have these numbers, I also gave a hack around that we are able to simulate traffic. So scaling your infrastructure is easier now with automation. We are able to automate that and see, assuming my business gets Eureka, how is it going to react? The front end, the back end, all that. And then the business part too. What do I need to reach the target audience? He talked about cash. Branding, advertisement, promotions, campaigns, online, digital marketing, conferences, like everything. So everything comes together when you're thinking of what? Scaling at large. So you cannot And then you find it difficult to predict all these things because they are all forecasting on your own. But make an attempt to engage experts. There's somebody who is doing that already. Look for the partners, and there'll be a synergy. There'll be a way you come together, and then you forge the forces, and then you get your things done. Yeah.
Well, I think I'm also, I agree with him on most of the things that he said. For me, being someone into, let's say, hardware, I would first say you need to identify your target market, know the size of your target market, and then also look at your production. Okay, what's the rate of your production? For example, if you receive, let's say, 5,000 orders, what's your lead time? How quick can you service all those orders? It's really important that you look at these numbers so that in an attempt to scale your business, you don't have people calling you all around and still you are not able to, provide these clients what they are looking for. So you also look at your team. You also look at your team and your expertise, because if you are running the business and you are small, if you get to a certain stage, the roles and the responsibilities may need some changes. So you look at your team, would they be able to handle all that pressure? Because it's really, really important. Thank you.
All right, so to make it very simple, how many of you would be happy to use a solution that is disturbing you? How many of you would want to use a solution that makes you angry? So one of the key things that you need to look at when you want to scale is the fact that you have a happy customer. A happy customer. If you are giving it to 10 people and they are happy, the question is, when I give it to 1,000 people, would they be happy? So you're looking at your user being happy. Happy here means satisfied. Now, there are variables to talk about satisfaction when it comes to the input of the user. So you want to make the user happy because the user desires what you're giving to the person. You want to make your user happy because they are getting value for money. And you want to make your user happy because what you've given to him or her was technically properly designed, thinking about them. And all of these things will make the user happy. That you thought about me, what I'm using, I'm paying for it, but I'm getting value for what I'm paying, and I like what I'm using. So to scale, make your user happy. And that involves all the variables that you need to make sure that that happiness is met.
Yeah, thank you. Although I am not a businessman, so I'll try to answer it from a different perspective. Yes. Yes. No, the whole thing is like, before you come up with any product, you have to do what we call market research. Because sometimes we have good ideas, but the point is the market ready? If you do your market research, then you know what to do at any point in time. Most of the times, like those of us in academia, we have good ideas, but we can't make money out of it because we don't know how to do the market research. So those of you who are in the business environment, if you want to have anything in the market, the first thing is do a thorough market research. So at any point in time, if you want to scale up anything, you know exactly what to do. Thank you.
I agree to everything. It's always a bit difficult to be the fifth person with the same question. So I want to bring a slightly different perspective, and that is our own perspective. We are not in the B2C market. We are in the B2B market. So we're not selling to 1 million customers. We're selling to 10. And we are selling to 10 customers that are not here. Europe's combined GDP is 250 times bigger than Ghana. So doing your market research, knowing that this talent is available in this room, we are thinking about selling B2B solutions to Europe. Why? Simple, because that's where the money is. What does it mean for us to ensure scalability? A couple of times we fell into a trap. If we talk to a large organization in Europe, and we are super happy that they are happy, your point, right? So you're absolutely excited that your solution is solving a problem and the client sees it the right way. It's cool that they're happy, but don't be too accommodating because that costs money, right? I'm adding a feature here, I'm adding a feature there, and all of a sudden your costs are just, going ballistic. So my only message is, if you're in the B2B business, you have a client, the client should be happy, absolutely agreed, but you should also need to be aware of, I'm happy because I'm selling, but I need to balance the finance, how do I get money to scale, with all the other operational items to make sure that I have the strength for scalability, actually. And I wanted to a follow-up question to you, Abdul, because you said you investigated 9 months into finding a solution for a power supply. How did you survive 9 months? Can you comment? I mean, because I think this is a practical challenge also for us. How do we find the funding for scalability, right? And it's our product, so we are super excited about something that resonates, but at the end of the day, we have invoices to pay also. Where does this very practical view come into play to make sure that scalability also means that you're making money with it? And sometimes that gets forgotten if you're carried away because you're so idealistic about your own product, right? But also your wife has demands that, should be fulfilled. So Abdul, how did you survive?
All right, how did I survive the 9 months? It was really, really tough. So during the 9 months, sometimes I miss lectures, especially getting to the tail end. Sometimes some of the courses, I would say, throughout the semester, I attended not more than 3. Because even when I'm sitting in the lecture hall, I'll be thinking about the solution. I can't pay attention. Because the thing was bothering me. I've invested all my money into the projects, yes, and I will say this, for 2 years, okay, 3rd year and my final year, I'm going to say this, I'm not telling you to try it. When my parents gave me money for my hostel fees, okay, for 3rd year, I split it into 2. I used half of it to invest into the prototyping, and the other half, I went to Bonsugate and got a homestay. That was where I was staying. Final year, I needed more money because I was almost at my goal. So I used all the money they gave me, and I was splitting with a friend. So that was how tough it was for me. Because if you tell them to give you money to do your prototyping, they don't believe in what you have like you do. So it's going to be really difficult to convince them to give you that capital that you need. So for me, that was how I did my best to survive. And I think it's paid off. Thank you.
Thank you very much. Before I go or we end, I've been asked to ask if any of you still have questions that you would like to ask our panelists. Please, you can still come forward. If you still have a question that you'd like to ask our panelists, yes, please.
My name is Bernard Godwame. I'm a final year computer engineering student. So my question is that from the very first presentation, you said if you are not embarrassed about your first product, it means that you shipped too late. And then The third presentation was like, we need to plan ahead and think long term. But some of us, we feel like if we don't have everything mapped out, for example, I'm building an application and then I've not thought about the full architecture, how everything is going to work when it begins to scale, and basically everything about your app, we just give up like at the start because you need to have full knowledge about the application. And then we also need to ship fast. Like, we need to not have the full idea based on what you said. You said your first prototype, you don't need to be too proud about it. So how do we balance thinking long term and then also being able to ship our prototype very quickly? So what are the minimum things that we should try to consider and be like, okay, even though I don't have the full idea right now, let me just start anyway. So what are the things that are the minimum requirements for us to just say, let me just start? Thank you.
It looks like that particular statement is ringing a lot of bells in your head. So my slides were structured from idea to large-scale production. So between the ideation stage to the first prototype was, you see, a clear example was his presentation. So his first analog circuit and in the ice cream, all those things. Is that what you are still using? No, good. And that one and what you have now, which one are you really proud of? The latter one, good. So the first one is frustration, but it communicates what he wants to do. Any visionary will see that product and can just envisage and say that there's something in this. So my boss is around, and he's not had a chance to see defense like this before. And it's like some fire is inside him because he knows he knows we as Heidelberg have what it takes to scale almost all the things that is in the lab. So yesterday he said he wants to take 10 national service persons, but the contact we have taken as at today is more than 10 because, Philip, I saw this person, he's excellent. The idea is brilliant. The another person is brilliant. So right now, we are going to now sieve the numbers. So at your level, you not see the difference, the long term he's talking about, okay? But once you get to that point where someone or yourself say that you want to scale it, the steps you have to take to get to the large is what he also said, that start thinking long term, start thinking people, start thinking connectivity, start thinking finance. But at the embryonic stage, like the egg hatching, when the egg hatching process, when the hen is on the eggs, nobody knows whatever is happening. But it will get to a point that the chick inside will gain enough muscles to break the egg. And then you have a chick out there. So at the embryonic stage, you don't really know what is happening. But between that stage that you are nurturing, you are giving it attention, micromanaging it, testing with 1 or 2 people. They are giving you quick feedbacks. Within that space, it becomes investor attractive. Witty investors will now look at the idea and say, I think there's business out of this. And even what it will become. The Facebook me, I first signed up, it's not the Facebook I'm using today. The first Facebook app, the feature that made it blow was the like button. The like button. Before they later introduced unlike. Now they introduce heart emoji because somebody is dead. Now you have no option than to like. You see, then they kept improving their product. Even now WhatsApp status, it has that problem. There's only heart. So when somebody posts, my uncle is dead, you can't do anything. Either you send a message as a DM that I'm sorry or have my condolence. If you heart, say, hey, this guy, my uncle is dead, he's hearting it. You see, so these are challenges, but they've introduced the stories and all those things, even in a live product. And you see with time, they will introduce all those things. You look at all the apps you are using, they are going through different phases. It's called product life cycle. It gets to a point where it's a fully matured product that is saturated. You can't even add more features. But don't stop when you're a prototype. If you don't come to the market early, somebody will become a market leader. That's the truth. It's your idea. Hey, the guy has stolen my idea. No, you didn't go to the market early. You prototype really fast. You look for investors who have the capacity to move you. Then they will help you shape at scale. They'll give you all the partners. Like he said, he had to call Pakistan. And Pakistan did the magic, true of us. Yeah. So you have the idea, the investor is ready, the funds are ready, the partners are ready, it can scale. So the prototype should happen fast. And he mentioned again, I referenced him, he said, at final year, he saw that this time is very due. So no hostel. You see, time is of the essence. So don't worry about that statement. It is deeper. So you prototype fast, it doesn't work, you do another one. You see, he was moving to the next one. And he realized that there were challenges there too. Then quickly he came back to think about scaling. So if you are having a prototype that is taking so much time, when are you going to even start exposing it to people to see, to even give you help? Do you understand? Yes. And then to scale it, we've talked about partners. If you think you have the capacity to even scale on your own without partners, your teammates can even be partners. Some of your team members have no people. Yesterday's meeting, someone said, build your network before you need them. So these are our partners. If he didn't talk to somebody in Pakistan, he would not even share his testimony.
All right. I want to add to what he's saying by giving you a particular word you should think about. Share. Share. Now, we believe in prototyping and scaling our product. But the real thing is that we are the prototype. We, the individuals that are coming up with a solution, we are the prototype. And your internal challenges will be given to the solution that you are doing if you don't solve them. So the word share I'm giving to you is that, are you willing to share your responsibilities with others? Are you willing to share ownership with others? Are you willing to share your idea so that people will criticize? So as an individual, the way to scale is to scale yourself on levels that will help your product to go. Because you can't scale a project if you are the only person. But you also need to scale your person to accommodate a lot of people. And so the word share becomes very crucial to you. Are you willing to put your product out there so it fails? That is prototyping fast. So you must put your product there and let people say this is work. Share it. Share that responsibility. Share that idea. Share that ownership. Don't be afraid to share. That's what I want you to do. So if you want to do it quickly, just don't be afraid to share.
All right. I just want to add, from my little understanding in business, they have something they call SWOT analysis. Because like in every business, you have to identify your strength, okay? What you think you can do best. Because the point is, once you want to enter into any market, you have other competitors, sometimes well-established ones. So you have to develop your strengths. And then look at your weaknesses. Because there are some markets, as soon as you enter, if you are not strong, a day or two, you are out. And then you look at opportunities out there, okay, at the right time, okay? And also you also look at the threat. So once you're able to consider all these factors, I believe at any point in time, you can survive. But if your interest is only about maybe fast, I just want to enter the market, that one you are likely to fail. So it's better you sit down and also look at the bigger environment. Thank you.
Any more questions from our audience? Any question? Okay, then we'll proceed with the last question. So my last question, or kind of your closing remarks for this plenary session is, our final years may want to let their projects leave their lecture shelf. Some people also would like to turn their ideas into startups. So what would be, you said a lot, you've given a lot of advice. What would be your go-to word or that sparking word that you would tell the students about how they can scale their products or why they should scale their products? I'll start with you, Mr. Bernard Jankowski.
Why should they scale their products? Well, I hope that everyone who is doing a final year project is actually quite excited about it. Yesterday I had the opportunity to talk to maybe 10, 15, 20 people about their final year projects. And maybe one bit of advice, and I'm sure there's much more common, is understand the context of the person that you talk to. It doesn't make sense to jump into the most technical detail in second 2 in a conversation when I'm standing in front of you, right? Explain to me the purpose, explain to me the problem you're trying to solve before getting into detail, and only if I'm interested. So I'm an engineer myself, and I had to learn how to sell myself or the products that we are producing, not by being too excited about the technology, but being really excited about the problem that I'm solving using the technology. And that still exists. So when you pitch your project to interested parties, especially in the B2B world, make sure that you understand where the person is coming from you are pitching to.
All right, thank you. Yeah, thank you. One thing that we are good at, especially those of us in academia, is prototyping. Sometimes we have good ideas, but they don't go far. So I believe this kind of engagement is very, very important and also timely. Bringing academia and also our partners under one roof. So what I can say to my final year students is it possible that you can make a living out of your project? That's the question. Because many a times we think that, oh, we go to university, final year project is another academic exercise. No. In most places, this is the time for you to showcase what you can do. Because we have people who are here, those with money who are ready to invest into your product. So make sure you advertise, make the right contact, and normally those who come under my supervision, most of the times I even ask them, are you sure this project is enough for you to live on it? If the question is no, then it means there's something wrong. So I will urge you to take advantage. We have our industrial partners here. Talk to them. Because sometimes it's difficult for you to approach them, but you are lucky we have brought them here, so make use of them. Thank you very much.
All right. How many of you want to succeed? My hand is up. He's saying everyone. Yeah, so why should you go for your project? You want to succeed. Scaling your project is the best way to learn how to fail. So you will know what works and what does not work. You are going to succeed knowing what does not work. And scaling gives you the opportunity to maximize the intelligence of knowing what does not work, so that you can take advantage of the principles, relationships, connections, resources, and all the available things that scaling gives to you to succeed. The reason why we are afraid to, the reason why we don't succeed is because we are afraid. Scaling will kill your fear. I want you to take that. Scaling will kill your fear. So go ahead, scale, so that now you can build the confidence needed to succeed. Thank you.
I think he mentioned that scaling your project is a way for you to learn and then fail. And I say, fail fast, but then learn faster. Your rate of learning should be higher than your rate of failing. As you fail, you learn faster. And I will say this, before you even think about scaling that project or that idea that you have, like Prof mentioned, it's very, very important that you do a market research, not just on your clients or your customers, but then the current solutions that is already in the market. So that you don't go and do the same thing someone is doing. How then do you compete with that person? Because most students, we sort of think inside the box as if we are the first to work on that idea that we have. But believe you, someone out there probably has done that thing, and probably even if you are able to scale, you can't even beat him on price. And we know in Ghana, most people purchase based on the price before thinking about the functionalities. So it's very, very important that you look at what people have done and then look at what you can do to beat that person, whether in terms of functionality, in terms of pricing, okay, in terms of business management, whatever angle you want to look at that from. So it's very, very important we put that into thought. Thank you.
So scaling. So let me introduce entrepreneurship as a term. To climax the whole thing. If you are here and you don't have an entrepreneurial background, please start looking into it. At the end of the day, you'll be called a businessman. Whether you write Python or you write whatever, you'll be called a businessman. So you see, from breadboard to a boardroom. The boardroom is not IT guys that are sitting there just like that. It is top CEOs and directors who are running business. You have a prototype. If you've not had a chance to manage business before, and your idea, you see a big company that offers similar products or more, if you don't have the strength today, don't be following people that, I hear this company, they pay more for national service, I'm going there. No. Try and look for companies that are aligned to your prototypes, and then go in there and gain all the experience. Whilst you're on the side, you are learning some through an incubator to become an innovator, or let's say an entrepreneur. After some years of working, you can gain some resources, and maybe you can start your journey. It's not everybody who just live here. From here now, I've gotten spirit. I want to have my company. You fail. Go, if it's a company, there are two ways of getting where you want to be. If you own MTN, aren't you going to be happy? You'll be happy. Okay, if you were a worker at Microsoft, won't you be happy? You'll still be happy. You see, by the time you are done with Microsoft at 50 or Apple at 45, and you come down to Ghana with all the money, that dream company, you can build it within 6 months, because the cash, you've accumulated enough of it to start yourself. And that time, you've gained a lot of experience. He mentioned he worked with what? Johnson and what? Johnson. So from that, he got what? He said, I gave $100,000. You didn't hear? Yeah. So look at a business that is in line with what you are interested in. Look for them. And that if you go for interviews, because of your interest, you pass.
Then they'll put you in as an entry engineer. Then you grow in the ladder. You do, because they have a lot of knowledge. You work with cross-functional teams. There's product-oriented delivery systems. You move between departments. You do other things, lead teams. Before you come out, all the mistakes we're talking about, you not face them because they will introduce you to best practice. And then you can do business in Ghana with international standards at the backbone of your business. So don't think of scaling as just right after this meeting, I'm going to scale. No. People will have the opportunity to scale even today. It can be luck, chance. Like fourth IRA can just point you today and that is it. Everything I'm saying is not applicable to you. But if it doesn't choose you today, don't worry. You can go through fourth IRA. By the time you get to some stage, they themselves, they will see you as a partner. And then they will create it for you. At Heidelberg, you can have that anywhere. So entrepreneurship is very important. There's not, oh, that course is 2 credit hours. Don't do that. Don't do that. Take it serious. Because once you get the knowledge, sometimes they even bully you around the table. You can't talk about money. You don't even know whether you are doing poor negotiations. And somebody will just invest just $5,000 and take 90% of your company. Then later you are going for prayer meetings that God will fight for you. Go for entrepreneurship, understand business, understand finance, understand everything that you need to know. Then you can become a very good businessman. Thank you.
Thank you very much. I hope we have learnt a lot. Personally, I have learnt a lot, and I'm going to take these notes down, and then my team and then the projects that we are working on, we'll see how we can scale it. God bless you. This ends the first plenary session.
Hello. Hi. Wow. It's been a very insightful session. I know some of you in your heads you are saying, Stella, what am I going to use this thing for? But that's the thing about listening to very skilled and intelligent people talk. You learn things that apply to you no matter who you are. For example, I don't know, but I personally didn't know that water is on the acidic part of the pH. I mean, underground water is on the acidic part of the pH scale. Or who knew? Who knew? You see, so we learn, no matter who you are, you learn from skilled and intelligent people. So we'll be starting with the second session. And but I just want to say once again, thank you very much to our panelists for the first session. We are deeply grateful. Okay, so without wasting much time, I'll just introduce our first speaker. So our first speaker is the Chief Software Architect for ITC. His name is Mr. Franklin Eleblu. Please let's give him a round of applause as he comes up.
Good afternoon. We've been sitting for long, and I think we should rise and stretch a bit to let the blood flow. Because as I sat there, the sessions were engaging, but I was feeling tired. So maybe move around, shake 2 or 3 people, shake hands, find their names if you don't know them, and then you can come back to your seat. Great. All right, so let's let's resume our seats. You may sit down so that we can save some time. In the interest of time, I'm going to cut down a lot of what I had planned to say. My topic is bridging the gap between research and industry, and a lot of that has already been touched on by the earlier speakers. So that makes my work easy and helps me also to cut down some more. Last year, I was privileged to deliver the keynote at this same conference. Being invited once is a privilege, but being invited twice is an absolute honor. I'm glad the organizers didn't say, that's it, no more Franklin. He would never be on our stage again, but here I am. Apparently the speech did not generate any exceptions or bugs, so I'm back. Now, in my career, I've had the privilege of working with technology and its intersection with real-world problems for over 2 decades. And in my area of work, speed, scaling, precision are not luxuries. They are not things you sprinkle on top of what you have. They are necessities for survival. But even after all these years, I still consider that the pace of innovation is staggering, particularly if you've been following happenings after 2020 with all these generative intelligence capabilities. Unfortunately, the truth is that the gap between research and industry remains wide, and it remains a stubborn obstacle that we must find ways of addressing. Now, let's be honest. A lot of the guys here in academia and a few industry people are here. But in academia, we value rigorous experimentation, peer review, the pursuit of truth, and in industry, what we value are speed, cost effectiveness, competitive advantage, and sometimes all of these happen at the expense of deep exploration. And this gap comes about because of a number of things, and I'll mention just a few. I had more listed. But we have different ways of measuring success. Those of you in academia, you measure success by publications, citations, contributions to knowledge. That's how you get your promotions. In industry, we measure success by profitability, bottom line, market share, and the ability to win customers. So this means that the same piece of work, which is seen as a breakthrough in academia, is totally irrelevant, or maybe totally irrelevant in industry. 2, we have different risk appetites. Researchers, as we see in the universities, often explore uncharted territory where failure is part of the process. I'm glad today failure has been celebrated. But in industry, there's a lot of pressure to succeed, especially in competitive markets. And so people in industry tend to avoid high-risk paths that may not yield returns, obviously. And this difference in risk tolerance can also make collaboration difficult unless both sides adjust our expectations. The result of this is that you can have groundbreaking research sitting in libraries collecting dust or even in journals, instead of powering solutions in the real world. On the other hand, those of us in industry, some of our problems, we try and get quick fixes instead of having research-backed breakthroughs. I'm going to skip. Okay, I'll just give this case study because it relates to me and the work we do at IT Consortium. We have tried to tackle this divide quite directly. I don't say this as the cure for the challenge I'm mentioning, but I say this as just a step that we have seen and taken. At IT Consortium, we run an AI and research lab. And this team is made up of some of the brightest and best minds from our universities. Some of the people there are from here. We've picked some from the computer engineering department in Legon as well, and tech, even UCC, universities that were traditionally not known for engineering. And we don't hire them to work on safe, predictable projects. We give them hard problems. And every time I've been here, I mean, I was here last year, the kind of projects and defenses that we saw impressed us. And we know that there's quality substance here, and I'm sure that we will be coming again to pick. We give them hard problems, the ones that might fail, but it's okay. And if they succeed, those solutions could transform our business and industry. But here's the interesting thing. We're very budget conscious, but we've determined in our business that for the research department, in fact, we are most generous with their budget. Not because their results are guaranteed, but because we know that what feeds us today is not what will feed us tomorrow. In technology, the winners are not the ones who are already building what the market will, the winners are the ones who are building what the market will need in 5 years. And that requires foresight, patience, and the courage to invest in research that may not pay off immediately. And that is the essence of bridging research and industry. So, what are some of the bridging strategies? We need to collaborate early, industry and academia. You know, too often, those of us in industry hear about research only after it has been completed, and the researchers learn about industry only after our products have been already launched. We need to collaborate more and earlier. Industry embedded academic projects should be encouraged. What do I mean by that? And a lot of that has been said today. Instead of treating final year or postgraduate research as purely academic exercises, universities can link them directly to industry challenges. This means that the student's thesis must solve a real operational bottleneck for a logistics company, or a master's project could optimize energy usage for a factory. And then we can have joint supervision, and we have tried this with Legon, where faculty and an industry mentor co-supervise the outputs of projects. I'll skip again and go to what you can do as students to bridge the gap. Number one, learn to speak both languages, and I'm not saying English and Twi. What I'm saying is that there's a language for business and there's a language for technical work. Those of us who come from the academia or engineering side of things only speak the technical lingo, and we don't understand anything about business. I'm glad you talked about scaling being two-pronged. You scale on the technical side, and then you scale on the business side. You need both legs to survive. But as a student, you will stand out if you can explain an algorithm's efficiency to a developer on the one hand, and then explain its commercial potential to an investor in the same conversation. That sets you apart. We had the CEO of 4IR tell us that don't start by diving deep into technical details in the second, that is second number 2 of your conversation. We don't even understand what you're talking about. So practice translating complex technical concepts into simple, value-focused language. That's something you all can and must practice. Number 2, work on more than academic requirements. Assignments and theses are important, but the industry looks for evidence that you can take an idea from concept to a usable product. This means you should look for opportunities to extend your coursework into something tangible, like an app, a hardware prototype. We've mentioned prototype here more than any other word since this conference began. Or a real data set analysis that solves a problem. Number 3, and pay attention to this one. You need to build a portfolio. Quite frankly, your first class is quickly forgotten if you didn't know. It takes a week for us to forget that you got a first class. Employers and investors do not just want to hear what you know. They want to see what you have done. Maintain a portfolio of projects on platforms like GitHub, Kaggle. How many of you know Kaggle? If you're in data science and you don't know Kaggle, that is the part of your problem. Or even a personal website. Include your role, the technologies you used, the problem you solved, and the outcome. Even small projects add up to tell a story about your abilities. 4, collaborate widely. Innovation often happens in the edges of disciplines. Work with students from business. I think it's been said in the question and answer time. In design, in agriculture. We heard about Farmerline. They were working with computer engineers, but their passion was in agriculture. Health sciences, and then gain different perspectives. This actually mirrors the cross-functional teams that you will work with in the workplace. 5, learn to network early. I think this has been said, it was said yesterday by Romeo, our CEO, that build your networks long before you need them. I will not go into details there. And then 6, embrace failure as learning. That has also been said here. Fail fast. Don't be afraid to attempt projects that might fail. We value initiative, creativity, and the resilience to learn from setbacks. Document what you tried, what worked, what you would do differently, because this shows maturity. I will skip again. Now, faculty, what can you do to help bridge the gap? So I've talked about the students. I'm going to what faculty can do. And then finally, I will talk about what industry can do. And then we will bring it to a close. Faculty, number 1, please, let's help to align research topics with real-world needs. I'm sure with the industry players here, if you are looking for problems that you can throw at students and you engage industry players, they will be more than happy to collaborate. Encourage students to choose project topics that address pressing local or even global challenges. It doesn't mean compromising the academic rigor. That's not what we are saying. But ensuring that their work has a clear pathway to application. Then facilitate industry partnerships. I think this one, I see that quite a bit is being done. And I applaud the computer engineering department. I mean, this is one of those initiatives. I think we should clap for. Yeah. And then this point, I don't know how it will be implemented, but I think it's important. Create flexible research pathways. What I mean by this is that not all valuable research outcomes need to be journal papers. You see, the reason why it is so is that is the only way our work or our research is recognized. You need to publish to get promoted. But could the university consider alternative outputs, such as prototypes or open source tools? Reward these contributions alongside publications in promoting, in the promoting and assessment criteria, so that we are encouraged to move our intellectual rigor along the industry line as well. And then lastly, let's support entrepreneurial thinking. That has also been said here. Offer workshops or courses on intellectual property, business models, technology commercialization, and so on, so that students can see the pathway beyond publishing or graduating. And then finally, what industry players can do. Number one, research or invest in research capacity. Don't wait for ready-made solutions from abroad. Fund or co-fund research teams in partnership with universities. This can be done through joint labs, scholarships for targeted projects, or sponsored competitions. I think there's some hackathon going on, and that's a good way to go. Industry, we need to provide real data sets for real challenges. Sometimes the universities have to synthesize data to be able to do what they want to do, you know. But if we can provide real data, you know, people who have accounts with the banks, and we can provide them anonymized data about those who have paid their loans and those who have not, that provides real data for analysis. Industry, let's engage in mentorship. Assign experienced professionals to mentor student teams or advise on research projects. This not only shapes better solutions, but also exposes your company to emerging talent. Let us be patient, but also focused. In closing, I will say that the divide between research and industry is a man-made problem. It is not a natural problem and does not have to exist. It exists because we have allowed the different priorities and languages to separate us. Again, by language, I don't mean Twi and English. When academia and industry work together, the results can be transformative. Can you imagine a Ghana where breakthroughs in AI, renewable energy, healthcare, agriculture, and fintech are born here and adopted worldwide? But it is possible. Hey, let me not get into trouble. Okay, it is possible to reset. Now I've balanced the equation. Our AI research lab at ITC is just one such bridge. The challenge I leave with you is to think about the bridges that you can build from where you stand, whether you're a student, whether you're a lecturer, or whether you are an industry leader. Thank you.
Thank you very much. I feel like calling one person to ask what you learned. Should I? No. Hey, you're supposed to be learning. Okay, let me share one thing I learned too. One thing that he said that struck me, and I really appreciate how much it is relating to the first session that we had. He said that when you are, you know, no matter, it's not every work that is brought out, right, that has to be published or turned into a publication. And so he was talking about how we can consider other alternatives like probably prototypes. And it struck me as a research assistant, a lot of the time we are mostly thinking about publications, but then there are also other ways, other alternatives. So that's one thing that struck me. Okay, apparently I didn't introduce myself. So before I introduce the next speaker, let me just introduce myself. My name is Mausi. Yes, for those of you who don't know me. Okay, so I will quickly introduce our next speaker. Our next speaker is from Sysmex. She's the Human Resource Manager, and she goes by Miss Benedicta Ajavon. So can we please...
All right. Thank you very much. I'm not Benedicta, but Benedicta is a human resource manager. Unfortunately, she couldn't make it. Something came up, so I had to just be here just to talk about what we've been doing. And I was so happy to hear, the contributions, from Franklin when he spoke about how or what industry can do. And my presentation will basically look at what Sysmex, an IVD company, has been doing specifically with KNUST, just to try and bridge this gap that Franklin spoke about. Kindly allow me to just give a brief introduction of Sysmex. Sysmex is an IVD company. We're into medical laboratory equipment. It was founded in 1968. Originally, it was called Twa Medical Electronics, and it's headquartered in Kobe, Japan. In the 1960s and 70s, we launched a revolutionary C101 hematology analyzer. In 1996, we went public at the Osaka Security Exchange. We rebranded into Sysmex Corporation now, and we have expanded into the American market. In the 2000s, we diversified into coagulation, urine analysis, and immunoassays. In 2019, we acquired Siemens, the IVD division of Siemens. So basically, we run that business now. In the 2000s, we focused on molecular diagnostics, digital pathology, AI, and lab automation. Okay, so just like I said, I will go straight into what Sysmex has been doing in this space. And this is our shared values. There's a Japanese word called anshin, and anshin actually means peace of mind. So that's what we try to do. So when we enter a laboratory, we enter a hospital, what we try to do is to give clinicians that peace of mind. Now that test results that patients, will very much, appreciate and would very much enhance the care that is given to them. So basically, we are into hematology, coagulation, urine analysis, and these are basically commitments we have to our customers to ensure a match quality in diagnostics. To our employees, we want to ensure diversity. So if you get to our office here in Accra, you have people who are coming from Nigeria and different countries. So we are a very diverse company. We are responsible for 24 West and Central African countries. We have 3 offices now, one in Ghana, one in Burkina Faso, and then we also have one in Nigeria. So we owe this peace of mind to our customers, to our employees, to our business partners, to our shareholders, and to the larger society, because we are trying to ensure that we provide society, we are responsible members of society by conducting our business adhering to the highest ethical standards, in addition to the laws and regulations. All right, so basically this is our training office in Accra. We also have similar offices in Germany, so our employees are trained here and also in Germany. We also bring people, customers, who may have the need for some trainings here in our office to train them. And then we also have the Sysmex Academy, where people can sign on and have trainings specifically for the lab and on clinical issues, where we can attempt to, especially for students, when we engage, just like I will show you in subsequent slides. You are signed on to the Sysmex Academy, where you can have series of trainings that are, you are also given certificates, so that by the time you move from school to industry, you clearly understand how these equipment and these projects that we have out there work. Next slide, please. All right. So these are basically our portfolios. As I mentioned earlier, we are into hematology analyzers for laboratories, urine analysis, coagulation, and also life science. And in all these, we have, semi-automated systems, fully automated systems, and we provide all the technical support for them. All right, so here we're looking at our collaboration with tertiary institutions, and we will limit it to KNUST. Of course, we do with other institutions, but we are here today, so I'll just show some pictures of what work we've done so far. Okay, so this was a project with GIZ when we signed to partner KNUST and University of Ghana, Legon, to ensure that, the previous slide, please. Yes, to provide equipment for hands-on training, expertise in biomedical technology and healthcare diagnostics, and to support human resource development through technical education. All right, so this was at the Faculty of Health Sciences when we donated a couple of equipment to the faculty to ensure that research work and other needs are met. And this we did with the objective of fostering student and faculty training through collaborative research and to bridge theory practice gap by exposing students to industry standards instruments early in their education, so that, just like I mentioned, when they come to the field, they are already, they've already had the hands-on training, practical trainings to be able to use these cutting-edge equipment. All right, next. All right, so for educational institutions also provide hands-on training with modern diagnostics, I've mentioned that. And then also, just like Franklin mentioned, to align coursework with real-world lab practices. So for those of us who are focused in the laboratory, we want to ensure that the coursework that is done, for example, the faculty, when they come out, they are not lost in the system, or, so that gap is bridged. All right, so this is one of the equipment. This is the UF4000. It's a fully automated urine particle analyzer. We also donated the XN550, which is also a fully automated hematology analyzer. And then the CS 1600, which is a coagulation or hemostasis analyzer to the faculty to enable this gap that we want to bridge to be executed. Okay, so these are some of the programs we run by way of our corporate social responsibility to our society. This was done a couple of months ago. Yes, so here, with GIZ leading the way, we've also worked with KNUST and University of Ghana. We've signed some memorandum of understanding to ensure that we get equipment, state-of-the-art equipment to the universities so that we achieve this collective objective that enhances the skills of our graduates and professionals in the biomedical engineering to improve national health delivery. Okay, so we've also engaged the engineering department at the University of Ghana for this train-the-trainer activity so that when they go back to school, they are able to train the students so that we are on the same path to achieving the results that we need. Okay, so I think that's just basically what SysMex has done at KNUST and other universities to attempt to bridge this gap so that students can have hands-on practical work so that when they get to the field, they are very much in line with what is happening in industry. Thank you very much.
Thank you very much. Okay, so I'll quickly introduce our next speaker. Our next speaker is Miss Christine Akwete Oakley of Guard the Future Technologies. Please let's give her a round of applause as she comes up.
Hello, good morning. My name is Christine Akwete Oakley. I'm a former student of KNUST. I graduated from here actually 2 years ago. I also did aerospace engineering. And I would say, as a student to another student, honestly, do not doubt yourself, because I never thought I would get a platform as this, but here I am today. It's a presentation, so I don't know. Okay. So before I start, I'd like to introduce you to Guard the Future Limited. We are an R&D company. We focus on research and development, and you can see from the picture that this is our team, just half of our team with our engineers and our CEO. Now, Guard the Future Limited was founded just January 2025, but actually we came from our parent company, which is GR&D, and has been in the UK for over 12 years. Now, for the past 6 years, we've had a partnership with Future Oil Fields and Services in Nigeria, and through that partnership, Guard the Future was born. Now, what do we do? First of all, with research and development, what we do is we listen to the industry, we learn of its challenges, understand the challenges, and then now we go back to the breadboard. We define, design, and supply innovative designs. This is our main ethos. This is what we live by in Guard the Future Limited. And honestly, I would say you cannot work with us unless you love to do research. Research is a very important and core part of being an engineer, because even let's say you make your first prototype and it fails, and you don't have to be afraid to fail. Everybody fails once in a while. So if your first prototype fails, you have to go back, do more research, find out what went wrong, and fix it. So in this process of research and development, that's where you find your innovative self. You find out all the problems you did wrong, you find out the issues with your prototype, and you fix them. Now, how are we bridging the gap? Bridging the gap is through collaboration, as my former speaker said. So here we are to bridge the gap. We are collaborating with students here. We've already reached out to the provost, and we are looking into every engineering aspect in KNUST so we can have an interdisciplinary engineering team, because we cannot do it from just one engineering team. We can do it from every engineering possible discipline. If you have a team with biomedical, software, computer, aerospace, mechanical, electrical, think of the things you can achieve. You can basically make any kind of technology you want to, because you have ideas from different perspectives of the whole idea. Now here we are to also enrich academics. We are also here to bring topics and ideas on our current technology. Our CEO is a very brilliant innovator. He comes up with the outrageous ideas. You think it doesn't exist anywhere. So if you think you're going to search online, do your research, it's a lie. You won't find anything. You actually have to be innovative yourself. Create all these technologies so that they can come to life. All these things, they don't exist anywhere in the world. We're also doing exchange knowledge programs. Here is where we take students for NSS, internships. We also organize workshops. So you can come to our industry, understand how we work, understand how our technologies work in the whole industry. You bring that knowledge back. And if you want to join us after your service, after your internship for full-time employment, you can still join us. So together, we aim to create meaningful opportunities that benefit both students and the industry, and also build strong bridge between academic learning and industry innovation. Next, our technologies. So I want to introduce just a few technologies that guard the future we have brought together. Now, our company, if I forgot to say, we are an IP company. We value intellectual property because we create technologies that do not exist anywhere. So if you are on board our team, you have an idea, our CEO will listen to you. If you want to make your idea come to life, he will ask you, what do you need to make it come to life? Sometimes he can give you a project to do. If you find your passion and you know that you want to do that particular project, he will give you all the resources you need to do those projects. So from GR&D, which is in the UK, we have the GARD U-line roller. That is a technology for the oil and gas industry. So I know most of you don't know much about it, so I wouldn't go very much deep into it. And then our other technology is the 3C solar thermal. So first, let's talk about the GARD U-line roller. It's a novel, cost-effective, universal system approach to conveyance designed and developed by our interdisciplinary team. So for this U-line, we used an environmental engineer, mechanical engineer, software engineer, and also an electrical engineer. So what this technology does is, for our conventional rollers that we have in the system, it costs thousands of dollars just to run one well operation per day. But for us, we can go into a well for just a few $1,000s per day. So we reduce the cost of well intervention for operators worldwide by 90%. Because we are reducing the OPEX, that's the 90% reduction, 100% reduction in fishing. This is where operators lose parts, maybe drilling parts, bits, screws, whatever, in the well. And sometimes they even need to see what is going on. But because of our design is an interlocking design. Please go to the next slide. It uses an interlocking design with screws. We have no screws. It's interlocking design where nothing comes loose. The whole machine stays intact. No matter how deep you go into the well, you lose nothing. So we have 100% reduction in risk of fish. It's very modifiable. So where we use our software engineer here in the U line is we had software engineers develop a software from scratch that not only does a whole analysis on the wells that we are given, we take the well data from operators, and what we do is we run well analysis to tell them that, oh, our tool string can actually reach the target depth they're trying to reach. Sometimes they want to set a plug, sometimes they want to just see what's going on. We have a camera attachment. They want to perforate and then be able to dig and get more oil. So we help in all these things. Now next, we move on to the solar thermal. Now this is a relatively new project technology, which we are bringing to KNUST first, and we will have a lot of topics for the students in final year next year on this project. So this is a project that harnesses mainly solar power for everything. We can get solar power, get hot water, and also generate steam. Now this is linked to a bigger technology, but I don't have the, let me say, clearance to say anything about that right now. But in due time, we'll all learn about it. So currently, this project is in the R&D stage, and we are about to build our first prototype. That is why we need the help of these students to help us design and optimize the best tools and our best tools and parts for this entire technology to work. So this is going to help us to send, help the rural areas to develop, because most rural areas, they don't have access to hot water even to bathe. They need to light coal, or they need to burn wood just to get hot water. But with our technology, they don't need to do that anymore. They can just do that and get it free of charge. They don't need to pay for it. So next, we have a breakdown of the solar thermal module. The first one is a lens, which can produce heat of up to 500 degrees Celsius, and it is between 60 to 80% energy efficient. So we lose less and use more. Next, this heat goes through a heat exchanger. That is, if the end product needed is hot water, it gradually heats the water to the temperature that is needed. We can use this in food processing plants, dairy plants, food powder processing plants, food preservation plants, and all that. Also, we have the steam generation model, which is connected to the heat exchanger. So here, the steam is generated for reasons that we would need steam. That's if your end byproduct is the steam. So lastly, so next, GR&D, we are worldly recognized because we're a very unique R&D company that have a success rate of 100%. Till date, we have not failed yet in our R&D because we are very unique and we do not give up. What I have heard from everybody who has spoken today has just resonated with the fact that if you're an engineer, one thing you can never do is give up. Never give up on your passion, never give up on your idea, never give up on your prototype. All you have to do is make it better, and it will work. And just trust me, it will change the world. Next slide, please. So these are some pictures from our recent workshop that we had with oil and gas partners in Ghana, because we have already commercialized our products in the US, Europe, Southeast Asia, and Africa. But we want to come more into Ghana because we want to build a hub in Ghana where we can bring the talents, locally made industry supporters, so that so we can give back to the Ghanaian economy and make the Ghanaian economy stronger. Next slide, please. So this is our team. We are quite new, so we don't have a lot on board, but I would say that we are definitely looking for new people to join us, especially new talent from the university, because I would say we're not much interested in getting people who are already experienced. It doesn't mean if you're already experienced, you don't qualify. You do. But we believe in having people who can learn, because that's how it sticks better. Because anytime we get people for the company. It's quite amazing. Like, people always come to me and they're like, I don't believe I'm qualified. I didn't do much internships. I didn't do much. And I always tell them that your competence doesn't define where you'll be tomorrow. Your knowledge level today doesn't define where you'll be tomorrow, because there's always room to learn, there's always room to grow. And trust me, GR&D, every day is a school day. The fact that you're an engineer doesn't mean you stop learning. It means you never stop learning. You just keep going, you adapt, you innovate, you create, you always do something new every time. So yeah, we are here to get new service personnel. Currently, we are just looking for software and electrical. That's why we are here at Technology Week. But it doesn't matter what you did or what you're studying, you are always welcome at GR&D. Thank you so much.
Thank you very much. Thank you so much. I want to be like you when I grow up. Okay, so for our Q&A session, I'll quickly introduce our next two panelists and then we move on. So we've already had him here, but then we'll have him again. We have Mr. Bernhard Janikowski. So please let's give him a round of applause. Okay, he'll be here soon, but then let me introduce our next panelist. We have Dr. Ian Adams Sokama Newyam, who is the HOD for Petroleum Engineering KNUST. Let's give him a round of applause. All right, so let's begin with questions from students. I'm sure there are lots. So please, if you have questions, kindly put up your hand so I can see you. Hello. Kindly put up your hand if you have questions. This topic is something that is very relevant to us, everything that has been discussed today. So please let's ask questions. Okay, if there are no questions, then we'll just begin. All right, thank you so much for being here. I think that from everything that has been discussed today, it's been shown that there's a big gap between industry and research. And Mr. Franklin, you spoke about how this gap is man-made, it's not natural. And so as an industry expert, right, what is something that you wish that, or what is the biggest misconception that you think that students have about industry that can be corrected?
Well, I think there's a conception when I myself was a student, students think that all that matters in school is grades. And once you manage to graduate with a first class, there's a red carpet from the Great Hall all the way to some pot. We lost the battery, so.
Hello.
All right, the control room, if you can change the battery. We lost the battery on this. All right, so the misconception that success in industry is simply a matter of cracking all your grades, getting a first class, and then there's a red carpet that awaits you into a successful career. Now that is false. And in fact, these days, it is being found that people who arrive on the scene with first class and nothing else are usually among the worst to hire. I am not belittling the importance of your academic pursuits, but what we are saying is that if you want to build bridges between academia and industry, then you must be interested in industry even while you are a student. And that's why I said some of the things that I said. That among other things, make sure that you have a portfolio. Begin to experience the real world. Go beyond engineering language and get to understand a little bit of what the people on the business side also say. And in doing these things, you will be preparing yourself to be relevant to industry and escape the misconception that all that matters is a first class.
All right, thank you very much. This is a question that I'll throw to anyone who wants to answer. Is there a situation where a research project is not or cannot be commercialized or translated into a commercial product? Are there such situations?
Well, yes, theoretically there may be, because, the outcomes of research can be in multiple stages. Someone might be researching something that becomes, whose output becomes an input to another research, which eventually becomes something that can be used to be commercialized. This question has brought to mind an interaction I had with one of our senior AI researchers in our company. This was, I had this conversation with him before COVID. This was before Gen AI became a thing, right? He's very brilliant, and we were looking for an opportunity for him to enhance his abilities. So we were proposing that he considers pursuing a PhD, and we would help him fund it. His response was, in a sense, you might find it provocative, but it was also peculiar. He said his current interest is not to add to the mountain of research publications, but that he finds that there's a lot or enough that has been researched which can be translated into viable commercial enterprises. And his passion is to look at what has been published and how we can use that to make useful solutions. So, to your direct question, whether every research has commercial value, it's a yes and no. At least to the extent that someone is willing to fund it, there is some commercial value. But as I said, if your research ends in a certain place that someone else must take to develop further into something that eventually becomes a commercial, yeah, indirectly your research has commercial value, but its output might not be something that can be used immediately by either businesses or consumers. That's what I would say about that.
All right, thank you so much. Unfortunately, for the sake of time, I would like to ask each of you to give us something to take home. And so I'll start with Mr. Janikowski.
First of all, sorry for being late. That's not a good German habit to be late to a panel discussion. Apologies. Lessons to take home, maybe a couple. I wanted to comment on what you said. Is every capstone project a success in the market? And the answer is absolutely no. No. I mean, you know statistics, maybe 1 out of 10, maybe 1 out of 50 will actually make it. But that's besides the point. Your project is a badge for you, right? Even though the solution in it itself might not be successful, the team behind it might be highly talented. It's still something that you should be using to market yourself. Sometimes financial success is not in your product, but in you, with the talent and expertise that you've accumulated by being here at KNUST. Maybe one other comment to your point. What we are talking with this university about is to create something that we will call the Ghana AI Hub, and I know there's already the Responsible AI Lab here, which is a concept that we want to replicate coming from Europe. Pretty simple. We want to bring together the entire ecosystem, meaning startups from university, private companies, VC funds, so that there is a platform for these ideas to actually be funded, become successful, and become governed. And that is something I'm super excited about, because I do believe that this is something that is missing here, is access to funding, right? How do you survive the first months of your entrepreneurship if you truly believe that your idea will make a difference? So that would be my comment.
Thank you very much. I would like to respond to the question that my colleague discussed before I come up with my closing remarks. You know, research, we have fundamental research. Then we have applied research. But we also have use-inspired research. Okay? So a research doesn't necessarily need to have a commercial value. For fundamental research, the goal is not on the commercial value, but eventually it brings some commercial value. For example, the discovery of gravity wasn't something that Newton could commercialize. But a lot of products have been built on that over the years, which has brought us more commercial value than if at that time he was thinking about just coming up with something that will solve a public problem. Okay? So we still need fundamental research, and we need researchers in that area to be very active. Unfortunately, in the global south here, we don't have a lot of funding going into fundamental research. So many researchers, very, very good researchers, are moving into use-inspired and applied research, because that's where the money is going. Okay? But we still need fundamental research. We need to understand, for example, heavy metals going into our lands due to galamsey, where they end up. There's no commercial value to that. Okay? If someone uses mercury in galamsey for the next 5 years, what is the life cycle of the mercury in the soil? We need to understand that. No one will pay you to do that. And you can't make money out of that. Well, maybe from an academic perspective. But that is something that we need to understand. So fundamental research is important. But we also have need for applied research. Someone taking the findings of the fundamental research and trying to create something useful out of that. Then we have use-inspired research. People want a solution for their daily lives. And so you can basically pick a fundamental or an applied research and turn that into a product that can be used readily. These three are all important. Okay? So it shouldn't be that every research will give us a product that we can readily sell. Now my closing remarks. I didn't even say anything, but I have, as a head of department for the past 2 years, I found that they go abroad, okay, where you have basically the ideas, the prototyping, the startups of technology spring up from the university and then goes into the industry. I didn't find that here. So I was very interested. Then I went into the industry. I've been very active, attending conferences, going to companies, talking to them, trying to find out how we could get the university and the industry working, especially the oil and gas side, where I have been active. Now, the challenges have all been mentioned by my colleague. But we need to be very intentional about industry. I think that is the main problem here. As a university, apart from this program that I think is very intentional about bringing industrial partners here to look at what academia can do, most of the programs that involve industry and academia is all one way. So it's either academia is looking for something from industry, or industry is looking for something from academia. But this one is different. This is mutually beneficial. We have something that we can show to industry. Hey, this is what we've been able to do with the little we have. Then industry comes in and says, okay, because you've been able to do this, we can support from here. I think this is the way to go. And so that is the very first challenge, intentionality. We need to be very intentional about industry academia. Then secondly, it is very difficult, how the university is set up currently, it is very difficult to get industry involvement. And this is what I mean. We are set up as a traditional university. Everything is traditional. From the way we communicate. For example, we communicate via letters. And I have found out that writing letters to industries, companies doesn't work. Okay? What works are proposals. But we are not set up that way. Okay? If I want a company to come in to support a program, I need to give them a proposal of how it will benefit them and how it will benefit the general society. But we are used to giving letters. We send letter and say, okay, we invite you, come over, and let's do something together. Leadership is very different. Okay? We are a very traditional paperwork leadership. Industries work very different. They are more thinking about the bottom line. They want things to be done very fast. Here, things have to go through the structures. We have a department board, college board, faculty board, academic board before something is changed. By the time we are able to to go through these bureaucracies, probably an opportunity there is lost already. So it has to be that we have our system structured in a way that it will make it easy for us to be able to communicate easily and deal with industry. So let's look at these things. If we want to get industry to work, we have to be very intentional, and we have to set up our system to be able to function the same way that industries want to function. I don't think I have time to add more, but the final thing will be that let's look at projects, final year projects that goes beyond a single department. For example, the products that you've developed, you are trying to do everything by yourself. For you are computer engineers solving an agric-related problem. Wouldn't it be great if you had, let's say, 2 computer engineers developing the code, you had a student from agric engineering department looking at that technical aspect, and you had someone from business school all working together in this project group? It can be done. But again, we are not set up for that. If this is done, how do you score the students? For example, in my department, if we want to develop a technology for petroleum-related problem, and we need to bring in computer engineering students, how do we get them working together? How do we get supervisors from the departments working? How do we score the students? What is the assessment criteria? I mean, these are basic things we need to iron out if we really want to get this institution functioning. And then the final thing will be looking at the recruitment process, bringing in staff who are open-minded and really want to develop the courage to talk to industry and get industry and academia working. Thank you so much.
Okay, so first, an answer to your question. Personally, I just think that any research project can be commercialized, but personally, it's about timing. It's because I would say that maybe the time that you are thinking about your project, doing your research, there's not enough information in the market. Like what Mr. Francis said, someone's output could be your input to your project. So it will be about timing. So maybe your timing is just not right, but when it's the right time, you'll be able to commercialize your project. And then what I would say the students should take home is, like what the HOD said, we have to collaborate more between academia and then the industry. And it doesn't only fall on the academia, as in the board of the school, the lecturers, it also falls on the students. Because if the students don't collaborate with the industry and they act like they're not interested, I can attest to this. When I was in school, I wasn't much interested in meeting industry partners. But it all changed in my final year, and I got much more interested. And that really opened my eyes, because I did my course because when I was little, I was always interested to know how planes are built, who made this, how does it fly in the sky, like what is going on. But when I started doing my aerospace and I was doing my internship at the Air Force, I realized that some of my colleagues were not in it for the engineering aspect. They wanted to be pilots, and that's a different thing altogether. So when I continued with my engineering course, I realized that I not only want to understand how these things are made, I also want to understand how to make them better for the future. How to make these things that are already emitting carbon into our systems and it's dangerous for the long-term use. How to think of ideas and solutions that would benefit the near future. How to think of ways to reduce fuel use. Because I know for the planes, sometimes they just dump the fuel mid-air if they need to land. That's not safe. So we need a more safe and sustainable solution to all these things. And I cannot sit down and say, I want someone to do it for me. No. If I have the idea, I want to push it. So that's how I found my passion, by talking to someone from the industry. And for my first year, it was hard. Everybody can attest to the fact that being an engineer in this school is not easy. You think it's easy, it's not. It's a lot of research, and I used to think my lecturers hate me. But I realized that the ones who are the hardest on you are the ones who love you. Because if they're not paying attention to you, they will not challenge you. They will not push you beyond your limits. And as an engineer, that's what you have to do. You have to push your limits. If you don't push your limits, you're not going anywhere. Thank you.
Thank you. So my final words will be to the students especially, that stay curious and keep learning. Our industry is very fast moving. Assumptions change very quickly, and we have to continually question them. And we have to continually be upskilling every day. Make sure that you learn something new to continue to remain relevant. And that's one thing I'll leave with you. But before I hand over the mic, I also wanted to reiterate, or perhaps even clarify, the concept of prototyping, as we heard. One of the things that I want to bring to your attention as you embark on this journey is that one of the reasons for prototyping is to be able to get user feedback without spending a lot of money, seeing how things work. Okay, so prototypes can be very simple. You don't have to invest long hours of code. You don't have to invest in infrastructure, but you're just picking. That's what when we talk about user-centric design, which is an aspect of, what design thinking is all about. So prototyping does not mean build the whole software, and then when people start using it, you scale it. Prototyping is to give you feedback that informs things you change in a very cheap way until you can be sure that what you're about to ship is the thing that will work. And then you can marshal all your resources and put on it. So these are the two things. Continue learning
and remember the value of prototyping. Thank you.
All right, so I want to share just about 3 things that I want to leave with you. And today we've heard about scaling, we've heard about growth and all that. But at the end of the day, I want us to also look at what we give back to society. In the past couple of years, SMES has done so much in trying to do the best for our society, because at the end of the day, you will make the money, but you would have to give something back to where the people who gave you that money. So corporate social responsibilities, I think we should pay a lot more attention to that. I also want to talk about idea meritocracy. For those of you who own businesses, you're going to have young people coming through. These are people who have a lot of ideas to share. The exposures they've had, you may not necessarily have had those exposures. So you have to let better ideas win and be able to accept when you are wrong as a leader, and when there are people coming through who have so much to offer. Open your doors, listen to them, get their ideas, and then grow with those ideas. I also want to indicate that you have to start early. Don't think you have to finish school before you start that business. You need to start working on it. I've heard my colleague talk about when he started when he was a student. So you start early, you make the mistakes early, you learn from it. And once you are not going to give up, which I think has run through today, that we don't have to give up. We have to persist until we win. So I think that we should work on that. We also have to look at relationships. You may have a good product, you may have all the knowledge to push it, but if you are not good at your relationships, you may fail. So let us also work a lot more on the relationships we've created and basically leverage on it. I think that's what I want to leave with you.
Thank you all so much. And so we've come to the end of the second session. Thank you all very much. We've learned so much, and we are so grateful for the insights that you've shared with us. Thank you.
Thank you very much. Thank you very much. Today, if not anything at all, we've experienced 3 things. Patience. Because I know some were saying, Charlie, we are hungry. You need to go. But the other question is that, what time did you come? Most of us were not on time. Patience, endurance, and resilience. I think that usually with this initiative, the day 2 is where I would say the real meat is. Because if you are going to succeed, you have to learn how to work together and how to also translate whatever we are doing here into action. There are some few things that have been said, and I usually do not want things to just be rituals. So you're going to make some commitments. Franklin elaborated clearly, eloquently on what our students, our universities, and our partners must do. In fact, it aligns with the objectives of this particular Tweek. We want to get to a point where from next year, we start working together early enough. So this is to say that our industry partners here, before we leave, those in 3rd year, 2nd year, the ultimate goal is that we as engineering or as engineers believe that we are shaped by the process. It's the processes that we go through that results in whatever we want to get. So We want to get to a point where before our industry partners leave, we will have all the list of problems, all the dreams, all the things they want us to help them with. So that starting next year, the final year projects, even when it comes to internships, those who come to you to work with, we are building a pipeline that what they start with is what they'll end with as far as project is concerned. I think if we make some commitment to some of these actions, next year Tweek will be review, monitoring and review. Is that okay? So for those of us here, luckily, Tweek is also gathering data. You see, my brother said that universities are very traditional, but we've changed a lot of things based on feedback and interactions with our industry players. Now, very soon, next semester, you see some of our industry players in the lecture room as guest lecturers because we've changed some processes for that. We want to open these doors to you that we want to do co-teaching. So when, for instance, when it comes to software engineering, we want to see that we'll have Philip and Co. around when it comes to the delivery. We'll have ITC around. We want the process to start early. So number one, next year, our final year project, we want to start building together. If you support that, let's say, just give me a wave. Good, I see Franklin, yes. So that's number one. Number two, we also want to see us doing things when it comes to industrial visits and all that together as well. Okay, so we don't want to see our students struggling, they come, they can't get internships and all that, because we believe that working right from the beginning helps us to know who we want to work with and shape the actual attitude that we want to see in the students. So we want to do that as well. If we agree, let me see that from the industry people. So it appears I'm telling all this to the industry people. Now, to us as students, we will change our attitude. Chief amongst that, I texted Franklin this morning that your children are late. Or if I say children, you look too old. Your siblings are late. And this is what he told me. Be patient with them. This is how they are. Let's be patient with them. But I don't think sometimes patience yields certain results. We have to be very brute when we have to stop certain attitudes. Today, our people were late, and I want to apologize. That's why this session has been late. And they are promising that they will put on a good attitude, Franklin, and that will be their part. Their part will be attitude. As for the skills, we know they are good, but what is left is what? The attitude. So please, if we are late, forgive us. All our industrial partners, please forgive us. If you're a student here and you agree with my apology, let me hear a round of applause. So go and sin no more. So when we close this session, we'll go and have our lunch. Those the students, your association leaders sponsored today's lunch. Our guests, we will meet at the usual place to have interactions before the breakout session. Please, after the lunch, ACES, you have your eye conference here. You've promised that you have put on a new leaf. You are not going to sin anymore. So Franklin says I should forgive. I don't know why he has a big heart. And I'm sure he's representing everyone here. So I'm trusting you that when we leave, we'll all come back here. And our industrial partners, we know our breakout sessions. If you don't know, you can see me, and then we'll deal with that. So thank you very much for your patience, your perseverance, persistence, and we'll meet here in 30 minutes' time for the eye conference. Thank you very much. Oh, you love the hall so much that you don't want to leave. Okay.
you still sending group contributions to an individual's personal mobile money wallet? How do you track and account for the contributions? And how do you know all the money is used for its intended purpose? Welcome to Chango, your trustworthy group contributions app. Whether you're raising funds for a friend's wedding, an old school reunion, or any public campaign, Chango is your best.